Hi students, previous video I have done statistics marathon part 1 and now I am going to continue part 2 from correlation and regression. Before that, I request you all please subscribe to my channel, then it will be encouraging to me and I can share more and more videos with your requisition and with my interest also. Okay, please subscribe, like and share. Okay, now we will go to the topic. Next topic is correlation and regression. Before going to correlation and regression, what is meant by bivariate distribution? If the data is consisting of two variables, then it is known as bivariate data. If it is consisting of only one variable, it is univariate data. If it is consisting of two variables x and y and z like that, it is a bivariate data. The corresponding frequency distribution will be known as bivariate frequency distribution. Now coming to correlation. If there are two variables, there may be association between them. That means there may be relation between them. When we can say that two variables are related, that means the change in one variable may cause change in other variable directly or inversely. Directly means if one variable is increasing, other variable may be also increasing. Inversely means if one variable is increasing, other variable may decrease like that. Anyway, if one variable is changing, automatically other variable is changing means there is certain association, certain relationship between them. That type of relation is known as correlation. So when we can say that two variables are correlated, for a particular change in one variable, the particular change should be happen in other variable also. Then only two variables are said to be correlated. If it is not happening so, then they are said to be uncorrelated variables. Okay. There are different types of correlation. Positive correlation or direct correlation, negative correlation or inverse correlation, no correlation or nonsense correlation, linear and non-linear correlation. Now, if two variables move in the same direction, then it is known as positive correlation. That means if x increases, y variable value will also increase. If x decreases, y also decrease. Same direction. If the two variables move in the same direction, that is known as positive correlation. Okay, that means one variable increase, other variable increases. If one variable decrease, other variable decreases. Positive or direct. So please concentrate on the examples. Okay, price and supply. If price increases, supply increases. It is positive correlation. Height and weight, it is positive. Both variables move in the same. Yield and rainfall. If rainfall increases, yield increases. Rainfall decreases, yield decreases. Advertisement and sales. Okay, advertisement expenditure and sales. It is also positive. So mostly you have to concentrate on examples. Whenever two variables are given, so please check if one variable is increasing, other variable is also moving in the same direction or not. If it is so, it is positive. Okay, direct correlation. On the other hand, if the other variable, if two variables move in the opposite direction, that means if x variable increases, y variable decreases. If x decreases, y increases. Then that type of correlation is known as negative correlation or inverse correlation. Negative correlation or inverse correlation. Okay, two variables are moving in the opposite direction. Again, coming to that one examples. Best example is price and demand. Okay, price and demand. Price increases, demand decreases. Price decreases, demand increases. TV registrations and cinema attendance. Oh, we all know that nowadays OTT platform is very much increasing. That means cinema attendance is very much decreasing. It is a negative correlation. Okay. Similarly, if there is no relationship between two variables, then it is the case of zero correlation or absence of correlation. Height and marks, there is no relation. Okay. Similarly, intelligence and shoe size, there is no relation. These type of variables are said to be no correlation. If there is no relationship, it is known as no correlation, and two variables are said to be uncorrelated variables. Uncorrelated variables means zero correlation. Example, height and marks, number of children born and number of cars sold, shoe size and intelligence. These are all the cases of no correlation. Similarly, next definition is linear and non-linear correlation. What is meant by linear correlation? If the change is in constant ratio, that means, suppose, see here, if the two variables are plotted on graph taking x variable on x-axis and y variable on y-axis, and it yields a straight line, that means our variable values will be like this. X variable, for example, 1, 2, 3, 4, 5, and 6. Corresponding y variable values, for example, some 5, 10, 15, 20, 25, 30. Okay, what is happening here? X variable is increasing constantly. Every time it is increasing 1. Okay. Similarly, y also increasing. It is also moving constantly. Every time increase ratio, increase constant value is 5. Okay. So if the two variables are moving in constant direction, in the same direction means it is the case of linear positive, or it is also known as perfect positive. Linear means straight line. When the two variables behave in the constant manner, our graph will give you a straight line, and it is the case of linear. If we both are moving in the same direction, linear positive or perfect positive. Similarly, if the variables are like this, x variable is suppose 1, 2, 3, 4, 5. And corresponding y variable values are like this, okay? 16, 12, 8, 4, and 0. Okay, now what happened here? 8, 4, and 0 means here x variable is going to be increasing in constant manner. That means every time it is increasing in 1. Y variable, it is decreasing. X increases, y decreases, but it in the constant manner. Y every time it is decreasing 4 times. Okay, so this is the case of linear negative. Both variables are moving in opposite and constant manner. Linear negative, or it is also known as perfect negative correlation. So linear means straight line, constant manner means linear correlation. Otherwise simply non-linear. Non-linear means what is the non-linear manner? X, for example, sometimes it is increasing, sometimes it is decreasing, then it will come non-linear, curvilinear. Like then it is known as non-linear. Okay, so there are mainly these types of correlation. Positive or direct means both variables move in the same direction. Negative correlation means both variables are moving in the opposite way. Okay, no correlation means there is no relation between two variables. And linear or non-linear correlation means constant changes in both variables, whether it may be directly or inversely. Directly means perfect positive, inversely means perfect negative. Okay, that is linear correlation. Next, coming to bivariate frequency distribution. If you have taken frequency distribution for the two variables simultaneously like this, for example, x variable is some variable and y variable is another variable. There are some values for x variable, Nana. And similarly, there are some more values for y variable also. If you plot frequencies for both variables simultaneously, then such type of distribution is known as bivariate frequency distribution. For both variables, frequency are plotted simultaneously. It is known as bivariate frequency distribution, or two-way frequency, or joint frequency. Okay, here each frequency is known as cell frequency. Here cell frequency may be 0 or positive, but they will never be negative. Okay, no frequency will be negative. Okay, so coming to bivariate frequency, the important points you have to remember means, from bivariate distribution, bivariate means two variables. If you plot two variables frequencies simultaneously, it is bivariate frequency. From this bivariate frequency, you can develop univariate frequencies. How many types of univariate frequencies are there? We have two types. One is marginal frequency distribution. Marginal means both variables, you take all the values. That means for x variable, suppose you have developed frequencies separately for x variables. X variable values 1, 2, 3, 4 and corresponding frequencies. That means these totals. This total will give your frequency of x, frequency of 1, 2, 3, 4. Okay. This is known as marginal distribution of x. Similarly, for y variable also, you can develop frequencies separately, taking only y variable. Okay, 1, 2, 3, 4, 5 with corresponding frequencies means for y one variable, for y taking one value, the frequency will be the total, row total. Similarly, for 2, frequency is this one. If you plot those frequencies here, that means you have obtained two separate frequency distribution. One is for x and one is for y. These distributions are known as marginal distributions. Marginal distribution means univariate. Similarly, if you are not interested of all the values, only you want what is the frequency of x taking one value, then only one frequency you have required. Similarly, if I am interested only y taking the value 3, the frequency is this value. Like that, you can develop different conditions. For x, we have 4 conditions, and for y, we have 5 conditions. These distributions are known as conditional distributions. So, from a bivariate table, how many univariate you can form, Nana? 2 univariate. What are they? One is marginal distribution, and other one is conditional distribution. From a bivariate, univariate distributions can be formed in two ways. One is marginal, that means all variable values with corresponding frequencies. Conditional means each individual value of the variable and corresponding frequency. Okay, so these are the important points. Marginal distribution means if we make a separate distribution from bivariate frequency where we take aggregate of only one variable at a time, all the variable values and corresponding frequencies. Those are known as marginal frequency distributions. That means bivariate means we will have two variables, x and y. Marginal distribution of x and marginal distribution of y. That means how many marginal distributions you can form? Two. Okay, from a bivariate frequency, two marginal frequencies can be formed. Similarly, what is meant by conditional distribution? Separate values. For each variable, separate value is treated as separate frequency. Like that, how many conditional distributions you can form from a m by n bivariate table? Suppose you have m rows and n columns now. That means x is taking some m values and y is taking some n values. For each of the value, you can get a condition. That means how many conditions you can develop for x variable m. How many conditions you can develop for y variable n? That means total conditions will be m plus n. So this is the conditional distributions. For a 2 by 3 bivariate table, how many conditions you can form? 2 plus 3. For a 4 by 6 bivariate table, how many conditions you can form? 4 plus 6. Similarly, for a m by n bivariate table, total cell frequencies will be mn. Okay, this is the main point. Similarly, for a 3 by 2 bivariate table, how many cell frequencies you will get? 3 into 2, 6. Total cell frequency is always mn. How many conditional distributions? M plus n, where m denotes rows and n denotes column. How many marginal distributions? Always 2. X variable marginal distribution and y variable marginal, always 2. This is about bivariate frequency. Okay. Now coming to the measures of correlation, we have 4 measures of correlation. Scatter plot or scatter diagram, Karl-Pearson correlation coefficient, Spearman rank correlation, and coefficient of concurrent deviation. I will discuss briefly. Okay, main points only I am discussing here. In exam point of view, these are the main points. Coming to the scatter diagram. How can scatter diagram help? Scatter diagram helps us to find only the nature of correlation. That means by using scatter diagram, you can tell only the nature, not the value. Value of correlation is considered as correlation coefficient. It is denoted by R. But by using scatter diagram, you can't find R value. Only the nature of correlation can be found. By using scatter diagram, you can tell the type of correlation, only nature. Positive or negative or zero, perfect positive, perfect negative. Like scatter diagram, we can tell only the nature of correlation. That means only the type, not magnitude. Coming to all the other 3 measures, Karl-Pearson correlation coefficient or Spearman rank correlation or concurrent deviation, you can find both nature and also magnitude. That means you can tell the type rather than the value. R value can also be estimated. Correlation coefficient can be found by using Karl-Pearson correlation coefficient or Spearman or concurrent. But scatter diagram does not help us to find correlation coefficient value. Okay, a very important point. So scatter diagram helps only for finding the nature of correlation or type of the correlation, but not the value, magnitude. Coming to all these 3 measures, by using these 3 methods, you can find both nature and also magnitude. Okay. Yes, scatter diagram. What are the important points? If all the dots fall in the straight line in upward direction from lower left to upper right, it is the case of perfect positive. So remember the pattern of the diagram. Okay, lower left to upper right, upward direction. Lower left to upper right means upward direction in a straight line, perfect positive. If all the dots fall in a straight line downward, upper left to lower right, then it is the case of perfect negative correlation. If the dots fall around the straight line in upward direction, simply positive. Not in a straight line, but upward direction. That means lower left to upper right, upward direction around the straight line, positive. Similarly, if the dots fall around the straight line downward, upper left to lower right, downward, not in a straight line, only downward direction around the straight line, negative correlation. If dots are evenly distributed without any pattern, that is known as zero correlation. Okay. Scatter diagram only studies direction but not magnitude. Very important point. Similarly, scatter diagram can study both linear and non-linear correlation also. Okay. Scatter diagram can study both linear and non-linear. Coming to linear and non-linear correlation, these 2 types can be studied by scatter diagram method rank correlation method and concurrent deviation method. Only these three methods can study both linear and non-linear. Coming to Karl-Pearson correlation coefficient, it can study only linear correlation and it will not study non-linear. Anyway, scatter diagram studies both linear and non-linear. For large number of values, this is not the suitable method. Since for large number of values means more number of values means our scatter diagram will be more and it will not support. Okay. For large number of values, scatter diagram is not the better measure. These are the important points you have to remember in scatter diagram. Okay. Scatter diagram or dot diagram, both are same, or plot diagram. Since we are plotting the dots, it is known as dot diagram or plot diagram or scatter diagram. Okay. Only nature can be studied by using scatter diagram. Next measure, Karl-Pearson correlation coefficient. For measuring correlation coefficient between two variables, Karl-Pearson has defined a formula R of xy, correlation coefficient between xy, or simply rxy. Formula, direct formula is covariance of xy by sigma x into sigma y, where covariance formula is this one, sigma x, sigma y are standard deviations. You see the formulas in formula marathon or see in your notes. Okay. Similarly, by using no deviations method also, you can find correlation coefficient between R value. Mostly we use no deviations method only. Remember the formula. So what are the important points for Karl-Pearson correlation coefficient? Correlation coefficient, R value always lies between -1 and +1, both inclusive. Okay. So what are the limits of correlation coefficient clearly? -1 less than or equal to R less than or equal to +1. That means it can take -1 and +1 and in between values also. So correlation coefficient always lies between -1 and +1. Correlation coefficient is a unit free measure. It is a relative measure, Nana. Relative measure does not depends on units. So correlation coefficient is a unit free measure. That means it is a pure number. Pure number in the sense you are not expressing the units. Only answer you are expressing, not the units. Okay, na? Correlation coefficient is a relative measure, unit free measure, and pure number. If R is +1, perfectly positive correlated. -1 means perfect negatively correlated. If the R values lies between 0 and 1, it is the case of positive correlation. If R values lies between -1 and 0, that means in negative values, negative correlation. If R is exactly 0, it is the case of no correlation. That means two variables are independent. And only for dependent variables, correlation will be there. For independent, correlation will not be there. That means 0. Covariance will be 0 and R is 0. Okay. Independent variable means covariance becomes 0, R becomes 0. Independent means no correlation, uncorrelated. Correlation coefficient is a relative measure. It is independent of units. Already we have discussed that point, and it is a pure number. Very important point. Correlation coefficient is independent of change of origin and scale. It depends only on the sign. Okay, only on the sign of the scale. Okay, very important. Next, coming to Spearman's rank correlation. So specifically, rank correlation coefficient is used only for the case of attributes, qualitative variables. If the given data is qualitative variables, that means attributes. Then for finding the correlation coefficient between these two variables, in the case of attributes, we have to use Spearman rank correlation. You know the formula, R equal to 1 minus 6 summation D square by N into N square minus 1. Here D means rank X minus rank Y. Deviation between the rank is D. You have to remember this point. Always sum of deviations from the rank. Summation D is always 0. Okay. So summation D is always 0. Similarly, in the rank correlation coefficient, these 2 points are important. When both judges' ranks are in the same order, then summation D square will become 0. That means R is +1. Both judges are giving the same ranks to all the participants. Perfect agreement. R is +1, perfect agreement. If both judges' ranks are in opposite order, then R will be -1. That means perfect disagreement. Okay. So sum of deviations in ranks is always equal to 0. And if both ranks are in the same order, R will be +1, perfect agreement. If both ranks are in opposite order, R is -1, perfect disagreement between the judges. Okay. Next, concurrent deviation method. Very simple and casual method of finding correlation coefficient. Here I have to tell one point. Which is the easiest method of studying correlation? If he is asking like that, easiest method of studying correlation means scatter diagram. Which is the easiest and simplest method of studying correlation coefficient means always concurrent deviations. Correlation coefficient is different from correlation. Correlation coefficient means we are studying the value also. Correlation means we are not studying the value. R value ledandi correlation lo. Correlation coefficient antene R. So correlation coefficient ki manam 3 methods unnai: Karl-Pearson, rank correlation and concurrent deviations. Coming to scatter diagram, it just measure only the correlation, not correlation coefficient. Okay na? So ante what is the easiest method of studying correlation ante scatter diagram అని చెప్పండి. What is the easiest method of studying correlation coefficient means concurrent deviations method. Okay, so very simple and casual method of finding correlation coefficient is concurrent deviation method. In this method we attach a positive value or negative value, plus sign or negative sign. If the value, previous value is increasing to the next value, keep plus sign. If from compared to previous value, if the next value is decreasing, please put negative sign. Like that, concurrent deviation method will be given. What is meant by concurrent? Both the signs should be equal. Plus into plus is plus, or minus into minus is plus. That is nothing but C, number of concurrent deviations. Here the formula is plus or minus square root of plus or minus 2c minus m by n. Here m is number of deviations, Nana. Always m equal to n minus 1. Please remember this point. Okay na? Here m equal to n minus 1. N means number of pairs. Always m will be less than number of pairs. Since we neglect the first value, m is n minus 1, plus or minus square root of plus or minus 2c minus m by n. Here when to take positive and when to take negative. Coming to 2c minus m is positive, then take positive sign. If 2c minus m is negative, then take minus sign inside and outside the root. After calculating, you can get concurrent deviations coefficient. Here one of the important points here is easiest way of studying correlation coefficient is concurrent deviations method. Okay na? For short-term fluctuations, which is the best method? Concurrent deviations method. For large number of values, scatter diagram is not the suitable. For in that cases, large number of values, best method is concurrent deviations method. And some more important points for concurrent deviations method is if c equal to 0, that means there are no concurrent deviations. Concurrent deviations means number of positives. No positives means all are negative. So when c equal to 0 in concurrent deviation method, r is minus 1. If c equal to m, m means number of deviations, c is number of positives, all are positives. That means r will be become plus 1. If c equal to m by 2, that means half positive signs are there, half negatives. We can't get any conclusion. In that case, r will be 0. Please remember these points. This is about concurrent deviations method. Next, probable error. Probable error formula is 0.6745 into 1 minus r square by root n. Sometimes we may estimate correlation coefficient for sample. Instead of population, sample correlation coefficient can be estimated. Sometimes error may happen. That error is nothing but probable error. 0.6745 into 1 minus r square by root n. In present day exams, probable error is not asking here. In previous exams only probable error is there. Anyway, probable error formula is this one. Okay. Next, if r is correlation coefficient, then r square is known as coefficient of determination. R correlation coefficient means if r is minus 0.6, r square 0.36, and it is known as coefficient of determination. 1 minus r square is known as coefficient of non-determination. Okay. Similarly, root 1 minus r square is known as coefficient of elimination. This is about correlation. Okay na? So please remember the important points, and basically you have to concentrate on examples. 2 variables he may give and ask us which type of correlation is there. So please think whether 2 variables are moving in the same direction or opposite direction, or whether there is no relation between them. Like, okay, please concentrate on examples. Next, I will move on to regression. So after correlation, what is meant by regression? In correlation, just we are studying the relationship between 2 variables only. But coming to regression, we study the relationship between 2 variables in the form of an equation. That means, what is meant by regression? The mathematical relationship between 2 variables. Regression is the measure of average relationship between 2 variables, or it is also mathematical relation between 2 variables, or functional relationship between 2 variables is known as regression. That means here in regression analysis, we will discuss the relationship between 2 variables with the form of an equation, that is some y equal to a plus bx, or some x equal to a plus by, like that. Okay na? In the form of equation we are studying. In regression analysis, whenever you have an equation, you can estimate the value also. Suppose if x value is given, what will be the y value? If y value is given, what will be the x value? This estimation, prediction can also be done in regression. So in regression analysis, what we are going to do? We are estimating the mathematical relationship, that is functional relationship, and also predicting the variable value. in prediction, we have two types of variables, dependent variable and independent variable. What is meant by dependent variable? The variable whose value is to be found is known as dependent. Suppose x variable value is given and you have to estimate y variable value. Then here y variable will be the dependent or explained variable, dependent or explained. That means the variable whose value is to be found is known as dependent. Independent variable or explanatory variable, the variable whose value is already known. Suppose he has given x equal to 20 and you have to estimate y variable value. Here y is dependent variable, x is independent variable. Similarly, suppose he has given y variable value as 10 and estimate x variable value he has asked. Then x will be the dependent and y is the independent variable, like that. Okay. So based on that concept, we have two regression lines or two regression equations. One is regression equation of y on x and other one is regression equation of x on y. Coming to regression lines, and actually both are same, but coming to graphical method, they are termed as regression lines. So regression lines, if the regression is expressed graphically, they are known as regression lines. There will be two regression lines as usually, regression line of y on x and regression line of x on y. The two regression lines intersect at the point x bar comma y bar. Very important point. Two lines intersect at the point x bar comma y bar. In the case of perfect correlation, that means of r equal to +1 or -1, two lines will coincide each other and form as a single line only. In that case, we will have only one line. That means very important. So if is r equal to +or -1, the two lines coincide and form a single line, and angle between these two lines will be 0 degrees. Okay, please correct it. It is 0 degrees, not 90 degrees. Sorry. So 0 degrees. It is 0 degrees. When r equal to +or -1, angle is 0 degrees. Similarly, if r equal to 0, the two lines will get perpendicular to each other like this. Okay, na? This is x on y and this is y on x. Angle will be 90 degrees. Here angle is 90 degrees. So when r equal to +or -1, angle is 0 degrees. When r equal to 0, angle is 90 degrees. Please remember these points. That means angle is depending on correlation coefficient. If what is the relationship between angle between the two lines and correlation? Inverse relation. That means if correlation is increasing, angle is decreasing. See here, Nana. If r is +or -1, angle is 0, decreasing. Okay, na? Correlation coefficient increases, angle decreases. Correlation coefficient decrease, r becomes 0, angle increase 90 degrees. Okay, na? There is inverse relationship between correlation coefficient and angle of the two lines. Okay, this is about regression lines. Now coming to regression equations. Regression equations can be expressed as two types again, y on x and x on y. What is the formula of y on x? Y minus y bar equal to r sigma y by sigma x into x minus x bar, or y minus y bar equal to byx into x minus x bar. When we have to use regression equation of y on x? When y is dependent and x is independent. That means if x variable value is given and you have to find y variable, then use the regression equation of y on x. Y is dependent, x is independent in y on x. X on y means x is dependent and y is independent. Y variable value will be given and you have to estimate x, then you have to use x on y, where the equation is x minus x bar equal to bxy into y minus y bar, or x minus x bar equal to r sigma x by sigma y into y minus y bar. Simple form of y on x is always y equal to a plus bx, and simple form of x on y equation is x equal to a plus by, where a and b are known as regression parameters. Okay, and here y is dependent. In y on x, y is dependent and x is independent. A and b are regression parameters. Here also x on y means x is dependent and y is independent. A and b are regression parameters. B is known as slope. B is known as slope and A is known as intercept. Okay, next. Regression coefficients. In these two regression equations, the coefficient part, that means byx and bxy, r sigma y by sigma x and r sigma x by sigma y, these two are known as byx and bxy. These two are known as regression coefficients. So since we have two regression equations, we have two regression coefficients also. Regression coefficient of y on x is denoted by byx and regression coefficient of x on y is denoted by bxy. What are the importance of regression coefficients? These are the main points. The geometric mean of two regression coefficients is always correlation coefficient. If you have byx and bxy, then you can find r value square root of byx into bxy. or R square. Coefficient of determination is product of two regression coefficients. Product of two regression coefficients is R square. Nana. Here I have to tell one point. You know the limits between correlation coefficient, that is -1 to +1. Okay. Then R square limits are less than or equal to 1. That means 0 to 1. Now what are the limits of regression coefficients? R square is nothing but byx into bxy. So our two regression coefficients should be such that their product should always be less than or equal to 1. Limits of regression coefficient means product of two regression coefficients should be less than unity. That means less than 1. Okay. Next, all regression coefficients byx, bxy and r, all the three will have the same sign always. Will have the same sign. If byx and bxy are negative, r is negative. If byx, bxy are positive, r is positive. If byx, bxy are 0, r is 0. So all the three will have the same sign. Okay, both of regression coefficients have same sign. Same sign will also have correlation coefficient. Okay. Similarly, magnitude. If one of the regression coefficient is greater than 1, if suppose byx is greater than 1, other regression coefficient should be compulsorily less than 1. Okay. Similarly, if bxy is greater than 1, byx should be less than 1. No two regression coefficients will always be greater than 1. If one is greater than 1, other should be less than 1. Why? Because here we have discussed the product of two regression coefficients should always be less than or equal to 1 means if one is greater, other should be less. Both may be less, but both should not be greater. Please remember that point. Okay, this is magnitude property. Next, arithmetic mean of two regression coefficient is always greater than or equal to correlation coefficient. You know that AM is always greater than GM, Nana. Here what is AM? Two regression coefficients. AM means byx plus bxy by 2. AM is greater than GM. What is the GM of two regression coefficients? Correlation coefficient. Okay. So always AM is greater than GM means two regression coefficients arithmetic mean is greater than correlation coefficient. Next, regression coefficient and correlation coefficients have same sign. I have already discussed. If both regression coefficients are negative, correlation coefficient is also negative. If both are positive, correlation coefficient is positive. If both are 0, R will also become 0. Next, very important property. Correlation coefficient is independent of both origin and scale. It depends only on the sign of the scale. Okay. Similarly, coming to regression coefficient, they are independent of origin. That means they will not change whether you have increased the data or decreased the data. That means regression coefficients are independent of change of origin, but they are dependent on scale. So suppose u equal to a plus bx and v equal to c plus dy. That means x variable is changed to u variable by changing origin and scale. A is origin, b is scale. Similarly, y variable is changed to v variable, c is origin and d is scale. Already we have discussed it is independent of change of origin, but they are depending on scale. So regression coefficient of v on u, bvu formula will be, what is the scale of v? D. Okay, na? What is the scale of u? B. D by b. They are independent of origin but not scale. Scale vastundi. Okay, na? D by b into b by x. So bvu formula is d by b by x, and buv formula is b by d bxy. Problem part is also very important for this one. Two equations ఇచ్చేసి regression coefficient of v on u, u on v అడుగుతారు నాన్న. ఓకేనా, అదొకసారి చెక్ చేసుకోండి. Problem is important on this concept. Next, independence property. If two variables are independent, r becomes 0. Then r becomes 0. Two regression coefficients will also be 0. Okay, na? Next, limits of regression coefficients. Very, very important point. Already I have discussed. Two regression coefficients limits means their product should also be less than unity. The product of two regression coefficients must be less than unity. This is about regression. Okay, na? In regression, please go through the problems based on this topic, BVU, BUV, and y on x, x on y. When you have to use y on x, when you have to use x on y, please concentrate. Okay, this is about regression. Okay. Okay. Next, we will move on to the index numbers. So, what is meant by index number? Index number is a device which compare any economic variable which stood at two different points of time or two different points of places like that. For comparing two different points of time, how a variable is changing, how the price is changing, how the quantity is changing, like that, we are going to use index numbers. So index number is a ratio or an average of ratios expressed as percentages. Always index numbers are expressed as percentages. It is a ratio or average of ratios which are expressed as percentages. It is a relative number or relative measure which expresses the relationship between two figures. One is base and other is current. Okay. Base year and current year. There will be two periods in the index numbers. Okay. Base year is denoted by 0 and current year is denoted by 1 or n. Index numbers are used to make a comparative study such as changes in production or consumption, export, import, national income, cost of living, crimes, prices, quantities, etc. Any changes? What are the changes compared to the previous year or before previous year, current year, how it is changing? All can be detected by using index numbers. Mostly we will use price index number. Okay. Index numbers are known as economic barometers, which measure change in level of phenomena. Since we are measuring the changes of any variable which stood at two different periods of time, it is also known as economic barometers. We are studying with economic variable. Okay, na? Economic variable lo changes చూస్తున్నాం index numbers and economic barometers are. Index numbers serve as signs and guideposts in an economic highway. Okay, so economic barometers and signs and guideposts. Index numbers are special type of averages which are expressed in percentages. The values stood at base year serve as standard point of comparison. Nana, always one year is compared with other year. That comparable year is known as base period. The value stood at base period is always known as standard point of comparison. Always we compare with that value only. Okay, na? Very important point. The value stood at base year serve as standard point of comparison. Always index number of base year is 100. Okay, index number of base year is always 100. The base period should be a normal period. Base period which we are going to take should be a normal period which is far away from abnormalities. That means fluctuations, floods, wars, COVID cases like that. Our year should not be like that. It should be a normal period. Okay. Weights play an important role in construction of index numbers. While constructing index numbers, we all know that formulas. There are unweighted index numbers and weighted index numbers. Sometimes you take weights, sometimes you may not take weights. But taking weights will give relative importance to the index numbers. So weights play an important role in construction of index numbers. Price index numbers are mostly used index numbers. Mostly we will use only price index numbers. If specifically he was asking quantity index number or cost of living like that only, we will opt for that. Mostly we calculate and mostly we have discussed price index numbers formulas only. Okay, na? So most of the index numbers which are used is price index numbers. Here, very important point. What is meant by P01, Nana? Price index number of 1 on 0. Current year on base year. P01. Price index of 1 on 0. If you reverse, current year becomes base year becomes current year. It is denoted by P10. What is P10? Price index of 0 on 1. So P01 means price index of 1 on 0 and P10 is price index of 0 on 1. I think you all know the formulas very well. Okay, what is the formula of P01? Price index of 1 on 0 means current year is 1, P1. By base year is P0 into 100. Similarly, if you reverse the times, that means 0 is the current year and 1 is the base year. Then our formula will be reversed, P0 by P1 into 100. Okay, that is P01 and P10. Next, I am not discussing formulas here. Okay, index numbers, we have several formulas. Already we have discussed in formula marathon, and please go through the formulas. In index numbers, formulas are very much important. Okay, as per index number, Passy index number, Bowley, Fisher, Marshall, Edgeworth, Walsh, Kelly, simple aggregate method, weighted aggregate method. Okay, please go through all the formulas. I'm discussing only the theory points which are important in exam point of view. Next, index numbers can be divided into many ways. Based on base periods, index numbers are two types: fixed base method and chain base index numbers. Fixed base index number means for all the index numbers construction, one base year will be fixed. Those index numbers are known as fixed base index numbers. Chain base index number means for every year, previous year will be taken as base year and we are going to compare year by year. That index numbers are known as chain base index numbers. Based on factors, that means sometimes we may construct index number for comparing prices. Sometimes we may construct index numbers for comparing quantities like that. Okay, price index number is one factor where quantities are considered as weights. Very important point. For price index numbers, what are the weights? quantities. For quantity index numbers, what are the weights? Prices. Okay, if you are constructing, if you are measuring the changes in prices, it is known as price index number. If you are measuring the changes in quantities, it is known as quantity index number. Anyway, for price index, quantities are considered as weights. For quantity index numbers, prices are considered as weights. Mostly used index numbers are price index numbers. There are some other index numbers also, cost of living index number, value index number, like that. Okay, based on factors, index numbers can be divided into many types. Based on commodities, very important. If you have only single commodity and if you are measuring the changes in those commodities, in that commodity only, that index number is known as simple index number. That means index number which is constructed for single commodity is known as simple index, or it is also known as relative. Price relative means we are measuring the changes of price of a single commodity for current year and base year. P1 by P0 into 100, price relative. Quantity relative, Q1 by Q0 into 100. Single commodity means relative. Composite index number, you have not a single commodity, group of commodities. For all those group of commodities, we are measuring the changes in prices or quantities, like that. So those index numbers are known as composite index numbers, which is constructed for group of commodities. Always for decision making, we will use composite index number. For decision making, which index numbers we are using? Composite index numbers. What are the important points in index numbers? Already I told, I am not discussing the formulas here. Please remember the formulas. Main points are here. Theoretically, the best average in the construction of index numbers is geometric mean. You all know that Fisher index number is known as ideal index number. That means in index numbers, which is the best average? GM. But GM is not so simple. In that cases, we will use arithmetic mean. But theoretically, best average in index number is geometric mean. Fisher index is known as ideal index number. Why it is known as ideal? Since it is satisfying time reversal test and factor reversal test. Tests of reversibility. Since it is satisfying both tests of reversibility, TRT and FRT, it is known as ideal index. Fisher index is the geometric mean of last price index and past sales index. Bowley index number is the arithmetic mean of last price and past sale. L plus P by 2 is Bowley, and root LP, geometric mean of last price and past sale, is Fisher. Index number based on arithmetic mean is higher than the index number based on geometric mean. Always, you know, AM is greater than GM. Okay. So index number based on arithmetic mean is always higher than the index number based on geometric mean. AM is always greater than GM. Time reversal test means P01 into P10 equal to 1, which is given by Fisher. Okay, factor reversal test means P01 into Q01 equal to summation P1 Q1 by summation P0 Q0, which is known as value index number. Okay, P01 into Q01 equal to summation P1 Q1 by summation P0 Q0. It is also known as value index number. Okay. So if price into quantity is giving value, that test is known as factor reversal test. It is also given by Fisher. Circular test is the extension of time reversal test. That means P01 into P12 into P20 equal to 1. Circular test. Circular test is met by, now this is the main point. Which index number formula is satisfying which of the tests? You have to remember very carefully. Tests of adequacy is one of the important concepts in index numbers. Compulsorily, one bit will be asked in this concept, tests of adequacy. Okay, that I am discussing in this table. See here. So, simple aggregate method does not satisfy unit test, but it satisfies time reversal and circular test. Simple AM, it satisfies unit test and unit test only. Simple GM. Simple GM satisfies unit test and time reversal test and circular test, like that. So what are the main points we have to remember? Unit test is satisfied by almost all the formulas except simple aggregate method. Simple aggregate method does not satisfy unit test. Okay. Time reversal test is satisfied by 8 formulas. What are those formulas? It is very easy to remember. Simple aggregate, simple GM, weighted aggregate, weighted GM. Next coming from Fisher, Marshall, Edgeworth, Walsh and Kelly. 8 nana. So time reversal test is satisfied by 8. What are those 8? Simple aggregate, simple GM, weighted aggregate, weighted GM, Fisher's, Marshall, Edgeworth, Walsh and Kelly. Factor reversal test is satisfied only by Fisher index number only. Only Fisher index number satisfies factor reversal test. Circular test is satisfied by 3 formulas. What are those formulas? Simple aggregate, simple GM and Kelly's fixed rate. Very important concept. Please remember this points. Okay, na? Which formula is satisfying which tests. So coming back to that important points. So circular test is not met by any of the weighted aggregative with changing weights. That means Laspierre, Passe, Fisher, Bowley. All these formulas are not satisfying circular test. Okay. Circular test is met by only simple GM of price relatives and weighted aggregate with fixed weights. That is Kelly. Okay. PRT is the test which requires that the product of price index for year 1 on 0 and price of the index for 0 on 1, P01 into P10 should be equal to 1. Factor reversal test is the test which requires the product of price index and quantity index should give value index. Chain based index is the index method which permits the introduction of new item and deletion of old item. One of the important points. If you have to insert any new items, if you have to delete any old items, then which index number is useful? Chain based index. Since year to year comparison is made, in that index number only you can insert or delete new items or old items like that. Okay, then you can recalculate the entire. There is no necessity to recalculate the entire series since in chain based index year to year comparison is made. Okay. Base shifting is the technique of changing the old base period to new base period. Base shifting means changing the old base to new base period. Okay. Splicing means combining two or more series of index numbers constructed with different base periods. Okay. There are two types of splicing: forward splicing and backward splicing. Forward splicing means if new series is compared with old series, it is known as forward splicing. If new series is again combining with old, that means new base is converted to old base, forward splicing. But mostly we will use backward splicing where old series of index number is combined with new series, old base is converted to new base, old to new, backward, new to old, forward. Always we will use backward splicing only. Deflating is the technique to eliminate the effect of changing price levels. When there is inflation, what are the changes you have to make to face the effects of inflation? How to reduce inflation? That can be done by deflation. Deflation is the technique to eliminate effect of changing price levels. And consumer price index number is the index which measure consumer price or cost of living index, both are same. These are the indexes which are measuring how much the consumers of a particular class have to pay more or less for a certain basket of goods and services in a given period when there is changes in price levels. Whenever there is changes in price levels, basket of goods and services may affect. So how they are affecting, how their standard of living is changing. So without changing their standard of living, what compensation you have to give, that can always be calculated by using cost of living index number. It considers relative prices and also known as relative price index. Cost of living index number, consumer price index number, relative price index number, all are same. Okay. So please see in index numbers, main problems you have to focus is CLI, very important, and last period index number, Passe index number, Bowley, Fisher. How to calculate these index numbers? Simple aggregate method. Please focus on these problems. Cost of living is very much important. Okay. Next, in index numbers, last concept is purchasing power of money. The reciprocal of price index. The reciprocal of price index is always purchasing power of money, or 100 by CLI is purchasing power of money. Okay. Projected wage. Amount he should receive. This we have done in problems also. In CLI, this is very important topic. To find new wage, what is the formula? Old income into new CLI by old CLI, then you will get new wage. Suppose if he is asking to find DA, what is the additional DA he has to pay? Means you have already find projected wage minus old wage. So new wage minus old wage will give you an additional DA. The DA to be paid is amount he should receive, that is projected wage minus amount that he actually received, old wage. Okay, very important point. Very important in problem point of view also. Now, shifting the base. Base shifting means original price index by price index of the year in which it has to be shifted into 100. This is base shifting formula. Okay, deflated value, current value by price index of current year, and real wage means money wage by cost of living index into 100. Wholesale price index number means in this index number the quantities of base year are taken as weights. Okay, this is equivalent to last year's price index number. These are the important points in index numbers. Nana. Please concentrate. Index number is very easy chapter if you know the formulas. Okay, please concentrate. Okay, next I will move on to probability, and next theoretical distributions. Okay. So next we will move on to probability. Okay. So what is meant by probability? Probability is the studies which are used extensively in the field of commerce, mathematics, physical science, medical science, weather forecasting, etc. So probability means chance. What is the chance of happening any certain event? What is the chance of getting right? All these will tell us about probability. Okay. Before going to probability, we have to keep in the mind the basic experiments like tossing of coin. When you toss a coin, there will be two outcomes, head and tail. Similarly, rolling of a die, a six-faced die, cubical die. Okay. Generally, the results will be 1, 2, 3, 4, 5, 6, and pack of cards. Generally, in pack of cards, there will be 52 cards where there will be 26 red and 26 black. Okay, 52 cards. 52 cards. Out of 52 cards, there will be 26 red cards and 26 black cards. Out of these red cards, again, 13 cards will be diamond cards and 13 cards will be hearts. Okay. In these black cards, 13 cards will be spades and 13 cards will be clubs. Okay. Like this pack of structure is given. What are these 13 cards again? Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen and king. Okay. These are the 13. That means how many kings we will have? 4 kings. In a set, 4 kings will be there. 4 jacks will be there. 4 aces, 4 twos, 4 threes like that. 4 13s, 52 like that. Okay, na? Please remember the structure of the cards. Okay. Here, jack, queen, king, king, jack, queen and king. These 3 cards are known as face cards. Okay, face cards. So now probability is divided into 2 parts, subjective probability and objective probability. What is meant by subjective probability? Based on previous experience, if you are telling what is the probability of happening, suppose a weather forecaster may in his experience say that today there is a probability of raining that is 80%. That is known as subjective. Based on previous experience, he was saying. Subjective probability is based on personal experience and judgment. It is very useful in decision management. Mostly decision management in industries, they will decide their probabilities based on their experience only. So in subjective probability is used mostly in decision management. Okay, na? Similarly, objective probability means deciding the probability by performing any trial or any experiment, that is known as objective probability. It is based on facts and analysis of measured observations. It is very much useful in different branches like mathematical sciences, medical sciences, stats, etc. Okay. So subjective means purely based on the previous experience. It is used in decision management, decision making. Decision making means subjective probability. Objective probability means it is based on repeated trials. Physically, we are doing an experiment and after that you are deciding, that is known as objective probability. Tossing of a coin, rolling of a die, pack of cards. These are all objective probabilities. Okay. What are the basic terms in probability? First one, random experiment. The experiment whose outcome cannot be predicted in advance. The experiment in whose all outcomes you are known. That means in tossing a coin, you know that head and tail are the events, but you can't expect which event may happen. Head ostunda, tail ostunda, mundu teliyadu. All events em untayo telusu. డై రోల్ చేసినప్పుడు 1 నుంచి 6 లోపు ఏదో ఒకటి రావచ్చు అని తెలుసు కానీ ఏది వస్తుందో తెలియదు. అలాగే ప్యాక్ ఆఫ్ కార్డ్స్ లో ఏదో ఒక కార్డ్ వస్తుంది కానీ కరెక్ట్ గా ఏ కార్డ్ వస్తుందో తెలియదు. ఇవన్నీ కూడా ర్యాండమ్ ఎక్స్పెరిమెంట్స్. సో ద ఎక్స్పెరిమెంట్ హూజ్ అవుట్కమ్ కెనాట్ బి ప్రిడిక్టెడ్ ఇన్ అడ్వాన్స్ ఈజ్ నోన్ యాజ్ ర్యాండమ్ ఎక్స్పెరిమెంట్. All the outcomes are known, but we can't expect the exact outcome which should happen. That is known as random experiment. Trial and event. What is meant by trial? Performing an experiment. మీరు కాయిన్ టాస్ చేస్తున్నారు, అదొక ట్రయల్. డై రోల్ చేస్తున్నారు, అదొక ట్రయల్. ఇవన్నీ ట్రయల్స్. ట్రయల్ మీన్స్ పర్ఫార్మింగ్ అన్ ఎక్స్పెరిమెంట్. ఆ ట్రయల్ చేశాక వచ్చే రిజల్ట్ ఉంటుంది చూడండి, అవుట్కమ్, వాటిని ఈవెంట్స్. కాయిన్ టాస్ చేయడం అనేది ఒక ట్రయల్ అయితే, హెడ్ రావడం ఒక ఈవెంట్, టెయిల్ రావడం ఒక ఈవెంట్. డై రోల్ చేయడం ఒక ఎక్స్పెరిమెంట్ ట్రయల్ అయితే 1, 2, 3, 4, 5, 6 ఇవన్నీ ఈవెంట్స్ అవుతాయి. ఓకేనా? సో పర్ఫార్మింగ్ అన్ ఎక్స్పెరిమెంట్ ఈస్ ట్రయల్ అండ్ అవుట్కమ్స్ ఆర్ నోన్ యాజ్ ఈవెంట్స్. శాంపుల్ స్పేస్. శాంపుల్ స్పేస్ వెరీ ఇంపార్టెంట్ డెఫినిషన్. శాంపుల్ స్పేస్ అంటే ఏంటంటే మీరు ఎక్స్పెరిమెంట్ లో ఉండే టోటల్ ఈవెంట్స్ లేదా టోటల్ అవుట్కమ్స్ ఇవన్నిటిని ఒక సెట్ బ్రాకెట్ లో డినోట్ చేస్తే దాన్నే శాంపుల్ స్పేస్. అంటే సింగిల్ కాయిన్ టాస్ చేశారు అనుకోండి, వాట్ ఆర్ ద టోటల్ అవుట్కమ్స్? సింగిల్ కాయిన్ అంటే హెడ్ లేదా టెయిల్ రావచ్చు. శాంపుల్ స్పేస్ ఈస్ హెడ్ కామా టీ. 2 కాయిన్స్ టాస్ చేశారు, మనకి ఎలా రావచ్చు? 1 tail 1 head రావచ్చు, 2 tails రావచ్చు, లేదా 1 head 1 tail రావచ్చు. ఓకే, బోత్ హెడ్స్ కూడా రావచ్చు. ఇది శాంపుల్ స్పేస్ ఫర్ 2 కాయిన్స్. లైక్ దట్ 3 కాయిన్స్ వేయచ్చు. సిమిలర్ గా డైకి తీసుకుంటే శాంపుల్ స్పేస్ ఏమవుతుంది? డైలో ఈవెంట్స్ ఏమేంటి? 1 2 3 4 5 6. 2 డైస్ వేశారు అనుకోండి, శాంపుల్ స్పేస్ ఏమవుతుంది? 1 1 1 2 1 3 1 4 1 5 1 6 2 1 2 2 2 3 so on 6 1 6 2 6 3 అట్లా. Okay, so sample space means the events involved in the experiment will consisting of a sample space. Sample space is always denoted by x, capital S. Okay, single coin toss చేస్తే sample space ఎలా ఉంటుంది? ఓకేనా? అవుట్కమ్స్ అన్నిటినీ సెట్ డినోషన్ లో డినోట్ చేస్తే దాన్నే sample space అంటాము. నెక్స్ట్ వెరీ ఇంపార్టెంట్ నాన్న, టైప్స్ ఆఫ్ ఈవెంట్స్. ఈవెంట్ అంటే ఏం చెప్పుకున్నాం? మనకు వచ్చే అవుట్కమ్ ని ఈవెంట్ అంటాం. దేర్ ఆర్ డిఫరెంట్ టైప్స్ ఆఫ్ ఈవెంట్స్. చూడండి, ఇంపాసిబుల్ ఈవెంట్. ఒక ఎక్స్పెరిమెంట్ చేసినప్పుడు ఏదైనా ఒక ఈవెంట్ రావడానికి ఛాన్స్ లేదనుకోండి, దాన్ని ఇంపాసిబుల్ ఈవెంట్ అంటాం. దాన్ని 5 తో కూడా డినోట్ చేస్తాం. నల్ సెట్ అన్నాం సెట్స్ లో. ఇక్కడ అది ఇంపాసిబుల్ ఈవెంట్. డై రోల్ చేశారు, 7 రావటం అనేది ఇంపాసిబుల్. ప్యాక్ ఆఫ్ కార్డ్స్ నుంచి బ్లూ కార్డ్ రావాలి అన్నాడు, ఇంపాసిబుల్. ఇవన్నీ కూడా ఇంపాసిబుల్ ఈవెంట్స్ అండి. ఓకేనా? ఇంపాసిబుల్ ఈవెంట్ రావటం అనేది ఉండదు, నల్ సెట్ అన్నమాట. సో ప్రాబబిలిటీ ఆఫ్ ఇంపాసిబుల్ ఈవెంట్ ఎప్పుడు కూడా ఎంత? 0. ఇట్ విల్ నాట్ హ్యాపెన్. ఇంపాసిబుల్ మీన్స్ ఇట్ నెవర్ హ్యాపెన్. షూర్ ఈవెంట్. నెక్స్ట్, షూర్ ఈవెంట్ అంటే ఏంటి? శాంపుల్ స్పేస్ ని షూర్ అనొచ్చు. అంటే ఒక డై రోల్ చేసినప్పుడు 1 గానీ 2 గానీ 3 గానీ 4 or 5 or 6 ఏదో ఒకటి షూర్ గా వస్తుందని మీకు తెలుసు. సో ఎంటైర్ ప్రాబబిలిటీ 1 అవుతుంది. ఓకే, దట్ ఈస్ నోన్ యాజ్ షూర్ ఈవెంట్. లేదా ఒక కాయిన్ లో మీకు రెండు వైపులా హెడ్స్ ఉన్నాయనుకోండి, ఎప్పుడు హెడ్ వస్తుంది. ఆ కేసులో హెడ్ టైల్ రెండు లేవు, ఓన్లీ హెడ్ ఉంది. ఎవ్రీ టైమ్ హెడ్ విల్ హ్యాపెన్. దట్ ఈస్ నోన్ యాజ్ షూర్ ఆర్ సర్టెన్ ఈవెంట్. షూర్ ఈవెంట్ ప్రాబిలిటీ ఎప్పుడు 1 అవుతుంది. ఓకే, షూర్ ఈవెంట్ ప్రాబిలిటీ 1 అవుతుంది. నెక్స్ట్, సింపుల్ ఆర్ ఎలిమెంటరీ ఈవెంట్. సింపుల్ ఈవెంట్, ఒక ఈవెంట్ ని మీరు స్ప్లిట్ చేయడానికి ఛాన్సెస్ లేవనుకోండి. డై రోల్ చేశారు, 1 వస్తుంది, వస్తే 1, 2 2 3 3 లైక్ దట్. అవన్నీ సింపుల్ ఈవెంట్స్. అంటే స్ప్లిట్టింగ్ కి ఛాన్సెస్ లేవు. మీకు క్లియర్ గా చెప్తున్నాను. సింపుల్ ఈవెంట్ అంటే స్ప్లిట్టింగ్ లేదు. కాంపోజిట్ ఈవెంట్ అంటే ఏంటండి? ఎలిమెంటరీ. నెక్స్ట్ కాంపౌండ్ ఈవెంట్. అది కాంపౌండ్ ఈవెంట్ అంటే ఏంటి? మీరు 2 డైస్ రోల్ చేశారు, సమ్ 6 రావాలి అన్నాడు. ఆ సమ్ 6 ఎలా రావచ్చు? 1 5 అయినా రావచ్చు, 2 4 అయినా రావచ్చు, 3 3 అయినా రావచ్చు, పవర్ 4 2 రావచ్చు, 5 1 రావచ్చు. ఇట్లా 6 ని డిఫరెంట్ ఈవెంట్స్ గా స్ప్లిట్ చేయొచ్చు. దీన్నే మనం కాంపౌండ్ ఈవెంట్ అంటాము. ఓకే, సింపుల్ ఈవెంట్ అంటే స్ప్లిట్టింగ్ కి ఛాన్సెస్ లేవు, ఓన్లీ ఒక ఛాన్సే ఉంటుంది. కాంపౌండ్ ఈవెంట్ అంటే ఆ ఈవెంట్ జరగడానికి డిఫరెంట్ ఛాన్సెస్ ఉంటాయి. ఓకే, చూడండి, సింపుల్ ఈవెంట్. సింపుల్ అన్నా ఎలిమెంటరీ ఈవెంట్ అన్నా ఒకటే. An event has only one sample point of a sample space, it is called as simple event. For example, in throwing a die, we get different simple events, 1 2 so on 6, only single event. Compound event, if an event has more than one sample point, it is called as composite event or compound event. Okay, for example, if 2 coins are tossed, the events of getting one head and one tail will be 1 head and 1 tail రావచ్చు, HT రావచ్చు, TH రావచ్చు. ఓకే, రైట్. ఓకే, there are more than one sample point. దీన్నే మనం కాంపౌండ్ ఈవెంట్ అంటాము. ఒక ఈవెంట్ ని స్ప్లిట్ చేయడానికి ఛాన్సెస్, అంటే ఆ ఈవెంట్ జరగడానికి రకరకాల పాసిబిలిటీస్ ఉన్నాయండి. అవన్నీ కూడా వాటినే కాంపౌండ్ ఈవెంట్స్ అంటాం. వెరీ ఇంపార్టెంట్ వన్. నెక్స్ట్ వన్, ఎగ్జాస్టివ్ ఈవెంట్స్. టోటల్ నంబర్ ఆఫ్ ఈవెంట్స్ ఇన్వాల్వ్డ్ ఇన్ పర్ఫార్మింగ్ ఎన్ ఎక్స్పెరిమెంట్. ఒక ఎక్స్పెరిమెంట్ లో ఉండే టోటల్ నంబర్ ఆఫ్ ఈవెంట్స్ నే ఎగ్జాస్టివ్ ఈవెంట్. అంటే శాంపుల్ స్పేస్ లో మనం ఏవైతే ఈవెంట్స్ రాసుకుంటున్నామో ఆ కౌంట్ ఏదైతే ఉందో, నంబర్ ఆఫ్ ఈవెంట్స్ ఇన్ శాంపుల్ స్పేస్, టోటల్ నంబర్ ఆఫ్ ఈవెంట్స్ ఇన్వాల్వ్డ్ ఇన్ ద ఎక్స్పెరిమెంట్ ఆర్ నోన్ యాజ్ ఎగ్జాస్టివ్ ఈవెంట్స్. అంటే సింగిల్ కాయిన్ టాస్ చేస్తే ఈవెంట్స్ ఏంటి మనకి? హెడ్ టైల్. సింగిల్ కాయిన్ కి 2 ఎగ్జాస్టివ్ ఈవెంట్స్. 2 కాయిన్స్ టాస్ చేసాం ఇందాక, శాంపుల్ స్పేస్ 4 వచ్చాయి, అంటే 4 ఎగ్జాస్టివ్ ఈవెంట్స్. 3 కాయిన్స్ అన్నాం, 2 క్యూబ్. సింగిల్ కాయిన్ మీన్స్ 2 power 1, 2 coins 2 square, 3 coins అయితే 2 cube. 10 coins టాస్ చేస్తే ఎగ్జాస్టివ్ ఈవెంట్స్ 2 power n. సింగిల్ డై రోల్ చేశారు, 6 ఎగ్జాస్టివ్ కేసెస్ ఉంటాయి. 2 డైస్ అయితే 6 square 36, 3 అయితే 6 cube, so on. So those are known as exhaustive events. Okay, if 2 events are said to be exhaustive. Exhaustive means total events, man, always total events. ఇప్పుడు కాయిన్ టాస్ చేశారు, as hast events ఏంటి head to tail, head probability 1/2, tail probability 1/2, రెండు యాడ్ చేస్తే ఎంత 1. If two events are said to be as hasty events, then always those total will be equal to 1. A, B as hasty events ante what is the condition? P of A plus P of B equal to 1. Similarly, if A, B, C are as hasty events, what will be your condition? P of A plus P of B plus P of C should be equal to 1. ఆ ఈవెంట్స్ అన్ని యాడ్ చేస్తే టోటల్ ఈవెంట్స్ అవుతాయి, టోటల్ ప్రాబిలిటీ 1 అవుతుంది as hasty events. Next, favorable events. What is meant by favorable? If you are interested only certain events, ఈ కొన్ని ఈవెంట్స్ మాత్రమే కావాలి, ఆ ఈవెంట్ కి ఫేవరబుల్ గా ఎన్ని ఉన్నాయి, నీకు కావాల్సిన ఈవెంట్స్ ఎన్ని ఉన్నాయి ఫేవరబుల్ గా, వాటినే ఫేవరబుల్ ఈవెంట్స్. సపోజ్ డై రోల్ చేశాను, 6 రావాలి అనుకుంటున్నాను, 6 కి ఫేవరబుల్ గా నాకు ఎన్ని ఈవెంట్స్ ఉంటాయి, ఒక 6 కదండి, ఫేవరబుల్ ఈవెంట్ 1. 2 డైస్ రోల్ చేసాం, 2 డైస్ రోల్ చేసినప్పుడు సమ్ 10 రావాలి అన్నాం. సమ్ 10 ఎలా రావచ్చు, 4-6 రావచ్చు, 5-5 రావచ్చు, 6-4 రావచ్చు. ఓకే, సో ఫేవరబుల్ కేసెస్ ఎన్ని ఇక్కడ 3. సో మన ఈవెంట్ కి ఫేవరబుల్ గా ఉండేవి ఫేవరబుల్. ఎస్హాస్టివ్ అంటే టోటల్ ఆల్ ఈవెంట్స్ ఎస్హాస్టివ్ ఈవెంట్స్ అంటాం. ఫేవరబుల్ మనం ఒక ఈవెంట్ అనుకున్నప్పుడు ఆ ఈవెంట్ కి ఫేవరబుల్ గా ఎన్ని ఈవెంట్స్ ఉంటాయో అవే ఫేవరబుల్ ఈవెంట్స్ అవుతాయి. ఓకే, ఫేవరబుల్ ఈవెంట్స్. సి హియర్, నంబర్ ఆఫ్ ఈవెంట్స్ ఫేవరబుల్ ఫర్ గెటింగ్ ఏ రెడ్ కార్డ్. ఎన్ని రెడ్ కార్డ్స్ ఉన్నాయండి, 26. సో 26 కార్డ్స్ నుంచి ఒక కార్డ్ తీయాలి, 26C1. నంబర్ ఆఫ్ ఈవెంట్స్ ఫర్ గెటింగ్ ఏ కింగ్ కార్డ్ అంటే ఫేవరబుల్ ఫర్ గెటింగ్ ఏ కింగ్ కార్డ్ 4C1. 4 కింగ్స్ ఉంటాయి, 4 లో ఏదో ఒకటి రావాలి. నంబర్ ఆఫ్ ఈవెంట్స్ ఫర్ గెటింగ్ ఏ బ్లాక్ కార్డ్ అన్నాడు, 26C1, 26 ఉంటాయి. సిమిలర్లీ వాట్ ఆర్ when 2 dice are rolled, number of events for getting some 10 అంటే 3 events favorable. Equally likely events, next important one. Equally likely means when 2 events probability are equal. Suppose కాయిన్ టాస్ చేశారు, హెడ్ రావడానికి ప్రాబిలిటీ 1/2, టైల్ రావడానికి కూడా ప్రాబిలిటీ 1/2. both events probability, when 2 events are said to be equally likely, both probabilities are equal, then it is the case of equally likely events. 2 events ఉన్నాయి ఈక్వల్లీ లైక్లీ అన్నాడు అంటే P of A P of B ఎంత అవ్వాలి, both 1/2 అవ్వాలి. 3 events ఉన్నాయండి ఈక్వల్లీ లైక్లీ అన్నాడు, A B C 3 ఈక్వల్లీ లైక్లీ, P of A 1/3, P of B 1/3, P of C కూడా 1/3. 4 events అన్నాడు, A B C D, ఈచ్ ఈవెంట్ ప్రాబిలిటీ ఎంత అవ్వాలి, 1/4. ఈక్వల్లీ లైక్లీ అంటే ఈక్వల్ ఛాన్సెస్ ఆఫ్ అకరింగ్. ఓకే, ఈక్వల్లీ లైక్లీ. నెక్స్ట్, మ్యూచువల్లీ ఎక్స్క్లూజివ్ ఈవెంట్స్. వాట్ ఆర్ మెant బై మ్యూచువల్లీ ఎక్స్క్లూజివ్? 2 ఈవెంట్స్ సైమల్టేనియస్ గా హ్యాపెన్ అవడానికి ఛాన్సెస్ లేవు. కాయిన్ టాస్ చేసినప్పుడు వస్తే హెడ్ రావాలి లేదా టైల్ రావాలి. దేర్ ఈస్ నో పాసిబుల్ ఛాన్స్ ఆఫ్ గెటింగ్ బోత్ హెడ్ అండ్ టైల్ ఎట్ ఎ టైం కదా. అలాంటివే మ్యూచువల్లీ ఎక్స్క్లూజివ్ ఈవెంట్స్. 2 ఈవెంట్స్ సైమల్టేనియస్ అంటే ఇంటర్సెక్షన్ పార్ట్ ఉండదు. ఏబి మ్యూచువల్లీ ఎక్స్క్లూజివ్ అనాలి అంటే రెండు కామన్ గా జరగకూడదు. ఏ ఇంటర్సెక్షన్ బి నల్ సెట్ అంటే ఏ ప్రాబిలిటీ ఆఫ్ ఏ ఇంటర్సెక్షన్ బి ఇంపాసిబుల్ అవ్వాలి, 0 అవ్వాలి. సో మ్యూచువల్ ఎక్స్క్లూజివ్ ఈవెంట్స్ అంటే ఏంటి, ఏ అండ్ బి మ్యూచువల్ ఎక్స్క్లూజివ్ అంటే P of A ఇంటర్సెక్షన్ బి 0 అవుతుంది. ఇన్ దట్ కేస్ P of A యూనియన్ బి, ఏ ఆర్ బి అంటాం. ఏదో ఒక ఈవెంట్ జరగడానికి probability of getting any one of them, A or B, A union B, P of A plus P of B. సో మ్యూచువల్లీ ఎక్స్క్లూజివ్ అంటే అది. ఇక్కడ ఈ 3 కలిపి అడుగుతున్నాడు మనని ఏమని, ఈక్వల్లీ లైక్లీ, ఎస్హాస్టివ్, మ్యూచువల్లీ ఎక్స్క్లూజివ్. చూడండి ఒక్కసారి, సపోజ్ ABCR ఈక్వల్లీ లైక్లీ అన్నారు, దెన్ వాట్ విల్ బి యువర్ కండిషన్? P of A equal to, P of B equal to, P of C equal to 1/3 అవ్వాలి కదా ఈక్వల్లీ లైక్లీ అన్నప్పుడు. సిమిలర్లీ ABCR ఎస్హాస్టివ్ అన్నాడు, then what will be your condition? P of A plus P of B plus P of C. ఎస్హాస్టివ్ means total will be equal to 1. ఓకేనా, ఎస్హాస్టివ్ అంటే ఇది. ABCR మ్యూచువల్లీ ఎక్స్క్లూజివ్ ఈవెంట్స్ అన్నాడు అంటే P of A ఇంటర్సెక్షన్ B ఇంటర్సెక్షన్ C 0 అవుతుంది. then what will happen? P of A or B or C, A union B union C ఏమవుతుందన్న P of A plus P of B plus P of C. సో ఆటోమేటికల్లీ ఈ 3 మిక్స్ చేశారు అనుకుందాం డెఫినిషన్స్. దట్ మీన్స్ ఇఫ్ ఆల్ ద 3 హ్యావ్స్ బీన్ మిక్స్డ్, దెన్ వాట్ విల్ హ్యాపెన్? ABCR ఈక్వల్లీ లైక్లీ అన్నాడు, 3 ఈక్వల్ అయితే P of A యూనియన్ B యూనియన్ C 1/3 plus 1/3 plus 1/3 ఎంత అవుతుంది? టోటల్ 1 ఎస్హాస్టివ్. ఓకేనా, ఇలా కండిషన్స్ చూసుకోండి. ఓకే, వెరీ ఇంపార్టెంట్ అన్న. నెక్స్ట్, కాంప్లిమెంటరీ ఈవెంట్. Complementary event means opposite event to our favorable event. Suppose A is favorable event, then opposite event A bar, That is known as complementary event. Suppose die వేసినప్పుడు ఈవెన్ నంబర్ రావటం అనే దాన్ని ఏ అన్నాం. ఈవెన్ నంబర్స్ ఏమేమి ఉంటాయి 2 4 6. దానికి ఆపోజిట్ ఆడ్ నంబర్ ఏ బార్ 1 3 5. సో ప్రాబిలిటీ ఆఫ్ ఏ ఎంత 2 4 6 అంటే 3 ఫేవరబుల్ ఈవెంట్స్ as has to 6 3 by 6 1 by 2. ఏ బార్ కూడా ఆడ్ నంబర్స్ 1 by 2. సో కాంప్లిమెంటరీ ఈవెంట్ అంటే ఆపోజిట్ ఈవెంట్. ఎవ్రీ ఈవెంట్ ఏ హ్యాస్ అనదర్ ఈవెంట్ ఏ కాంప్లిమెంట్ ఆర్ ఏ డాష్ which is known as complementary event. It is also known as event not A. Not A means A కాకుండా అని. ఈవెన్ నంబర్ కాదు అంటే ఆడ్ నంబర్ అని అర్థం. ఓకే, ఫర్ ఎగ్జాంపుల్ when a die is rolled, A represents event of getting an even number. Then A complement or A dash or not A represents not getting even number. That means getting odd number. Always A union A complement S అవుతుంది, అంతే కదా. ఈవెన్ నంబర్ రావడం అంటే కేసెస్ ఏమేంటి డైలో 2 4 6. మరి ఆడ్ నంబర్ అంటే కాంప్లిమెంటరీ ఈవెంట్ అంటే 1 3 5. రెండిటి యూనియన్ 1 2 3 4 5 6 శాంపుల్ స్పేస్ ఈక్వల్ అవుతుంది. శాంపుల్ స్పేస్ లో కొన్ని ఈవెంట్స్ ఫేవరబుల్ అంటే మిగతావన్నీ అన్ఫేవరబుల్ కాంప్లిమెంటరీ ఈవెంట్స్ అవుతాయి. రెండు కలిపితే శాంపుల్ స్పేస్ అవుతుంది. ఓకే, ఇంపార్టెంట్ టు రిమెంబర్ నాన్న, దిస్ ఇస్ ద పాయింట్ ఐ హావ్ టోల్డ్ ప్రీవియస్లీ. ఏబిసి ఆర్ ఈక్వల్లీ లైక్లీ మ్యూచువల్లీ ఎక్స్క్లూజివ్ అండ్ యాజ్ హాస్ టు ఎక్కువ అడుగుతున్నాడు ఇట్లాగా. సో 3 ఈవెంట్స్ ఈక్వల్లీ లైక్లీ అంటే వాట్ ఈస్ ద కండిషన్? 3 ప్రాబిలిటీస్ 1 by 3 కి ఈక్వల్ అవ్వాలి. ఇంటర్సెక్షన్ పార్ట్ మ్యూచువల్ ఎక్స్క్లూజివ్ అన్నాడు కనుక 0 అవ్వాలి. మరి అప్పుడు ఎగ్జాస్టివ్ అన్నాడు కనుక పి ఆఫ్ ఏ యూనియన్ బి యూనియన్ సి యాక్చువల్లీ పి ఆఫ్ ఏ ప్లస్ పి ఆఫ్ బి ప్లస్ పి ఆఫ్ సి. ఎగ్జాస్టివ్ అన్నాడు కనుక 3 ఈవెంట్స్ ప్రాబిలిటీ ఎంత అవ్వాలి? 1 అవ్వాలి. వెరీ ఇంపార్టెంట్. ఓకే, ప్లీజ్ రిమెంబర్. నెక్స్ట్, definitions of probability. Mathematical definition or classical definition or priori definition అని కూడా అంటాం దీన్ని. So suppose in an experiment there are n equally likely, mutually exclusive and exhaustive events and m of them are favorable to happening of event A. Then what is probability of A? A event probability అని ఎలా కనుక్కుంటాం? Favorable events by exhaustive events. This is the main definition of probability. మన టోటల్ ఎక్స్పెరిమెంట్ లో n టోటల్ ఈవెంట్స్ ఉన్నాయండి. ఆ n టోటల్ లో A అనే ఈవెంట్ కి ఫేవరబుల్ గా m ఉన్నాయి. అంటే ప్రాబబిలిటీ ఆఫ్ A ఎంత? m by n. రిలేటివ్ ఫ్రీక్వెన్సీ చెప్పుకున్నాం, ఫ్రీక్వెన్సీ బై టోటల్ ఫ్రీక్వెన్సీ, అదే ఇక్కడ ప్రాబబిలిటీ అవుతుంది. ఓకే, సో హియర్ m by n is known as relative frequency. Relative frequency or probability both are same. Next definition, statistical definition, okay, or empirical definition. So suppose an experiment is repeated more number of times, then in that more number of times an event A is happened only m times, then probability can be denoted by limit n goes to infinite m by n. దీన్ని రిలేటివ్ ఫ్రీక్వెన్సీ అప్రోచ్ అని కూడా అంటాం. ఓకే, స్టాటిస్టికల్ డెఫినిషన్ ఆర్ ఎంపెరికల్ ఆర్ పోస్టీరియర్ ప్రాబబిలిటీ. ఓకే, నెక్స్ట్ axiomatic definition. Axioms means properties. There are 3 properties here. Axiom of positivity. Axiom of positivity means any event probability will always be positive and it will never be negative. Impossible event means 0, or if it is the probability of any event, if it is not impossible, then it will be positive. So always event probability will always positive. A greater than or equal to 0. 0 means impossible, otherwise positive. Okay, this is known as axiom of positivity. A event probability అయినా పాజిటివ్ ఉంటుంది, నెగటివ్ అనేది ఉండదు probability. Axiom of certainty. If S is a sample space, certain event, sure event, total sure event probability, total probability ఎంత అండి? 1. అంటే ఆ శాంపుల్ స్పేస్ లో ఉండే అన్ని ఈవెంట్స్ ప్రాబబిలిటీ యాడ్ చేస్తే 1 వస్తుంది. దట్ ఈస్ నోన్ యాజ్ సర్టెన్, axiom of certainty. From these two properties, from these two axioms మనం ఏం చెప్పొచ్చు? Probability ranges from 0 to 1. 0 to 1. If it is impossible, it takes 0. If it is sure event, it takes 1. Otherwise, probability will range between 0 and 1. Okay. Third property is the axiom of union. If A, B are mutually exclusive, P of A union B is P of A plus P of B. Suppose A1, A2, so on, AN are mutually exclusive. That means P of A1 union A2, so on, union AN is P of A1 plus P of A2 plus so on, P of AN. Next, this is one next important concept is odds in favor and against. And most of the people are getting confused in this concept. Odds in favor అంటే ఏంటి, odds in against అంటే ఏంటి అన్న? ఇప్పుడు మీరు ఒక డై రోల్ చేశారు. డై రోల్ చేసినప్పుడు 6 రావడానికి ఫేవరబుల్ కేసెస్ ఎన్ని? 1. మిగతావన్నీ అన్ఫేవరబుల్ కేసెస్. అంటే ఇక్కడ ఆడ్స్ ఇన్ ఫేవర్ ఆఫ్ గెటింగ్ 6 అంటే ఆడ్స్ ఇన్ ఫేవర్ అన్నప్పుడు ముందు ఫేవరబుల్ ఛాన్సెస్ ఎన్ని ఉన్నాయి 6కి 1, మిగతావన్నీ కూడా ఏంటండి అన్ఫేవరబుల్. ఆడ్స్ ఇన్ ఫేవర్ అంటే ఇది, ముందు ఫేవర్ తర్వాత అన్ఫేవరబుల్, టోటల్ మళ్ళీ సేమే. ఇప్పుడు ఆడ్స్ అగైనెస్ట్ గెట్టింగ్ 6 అన్నాడు, అగైనెస్ట్ అన్నప్పుడు ముందు అన్ఫేవరబుల్ రాయాలి తర్వాత ఫేవరబుల్ రాయాలి. ఓకేనా? సో సిమిలర్ గా ఇంకా చూద్దాం కావాలంటే చూద్దాం. ఓకే, సిమిలర్ గా మీరు 2 కాయిన్స్ టాస్ చేశారు. 2 కాయిన్స్ టాస్ చేసినప్పుడు ఆడ్స్ ఇన్ ఫేవర్ ఆఫ్ గెటింగ్ 2 హెడ్స్ అన్నాడు. 2 హెడ్స్ రావడానికి ఎన్ని ఛాన్సెస్ ఫేవరబుల్ గా ఉంటాయండి? 2 కాయిన్స్ టాస్ చేసినప్పుడు ఒకటే కదా, హెడ్ హెడ్. సో ఆడ్స్ ఇన్ ఫేవర్ అంటే ఒకటి ఫేవరబుల్ గా ఉన్నాయి, మిగతా 3 అన్ఫేవరబుల్ గా ఉన్నాయి. ఆడ్స్ ఇన్ ఫేవర్ మీన్స్ 1:3. ఆడ్స్ అగైనెస్ట్ అంటే ఏం చెప్తాం? ముందు అన్ఫేవరబుల్ చెప్పాలి తర్వాత అగైనెస్ట్ చెప్పాలి. ఓకేనా? ఇంకా క్లియర్ గా చూడండి. ఇఫ్ P is the probability that an event will occur and Q is the probability of non-occurrence of the event, then we say that odds in favor of the event is P:Q. Favorable, unfavorable. ముందు ఫేవరబుల్ ఈవెంట్స్ ఎన్నో వేయండి, తర్వాత అన్ఫేవరబుల్ వేయండి. దాన్నే ఆడ్స్ ఇన్ ఫేవర్ అంటాం. ఆడ్స్ అగైనెస్ట్ అంటే ఏంటి? ముందు అన్ఫేవరబుల్ వస్తాయి తర్వాత ఫేవరబుల్ వస్తాయి. సపోజ్ మీకు ఆడ్స్ ఇన్ ఫేవర్ ఆఫ్ గెటింగ్ ఎనీ ఈవెంట్ ఈస్ 2:4 అన్నాడు. దెన్ వాట్ ఈస్ ద ప్రాబబిలిటీ ఆఫ్ ఫేవరబుల్ ఈవెంట్ అన్నాడు. ఫేవరబుల్ ఈవెంట్ కి ఛాన్సెస్ ఎన్ని ఉన్నాయి? 2 బై టోటల్ ఎంత అండి? 6. వాట్ ఈస్ ద ప్రాబబిలిటీ ఆఫ్ అన్ఫేవరబుల్ ఈవెంట్ అంటే ఏం చెప్తారు? 4/6 అని. ఆడ్స్ ఇన్ ఫేవర్ అంటే ముందు ఫేవర్ ఇచ్చాడు తర్వాత అన్ఫేవర్ ఇచ్చాడు. అదే ఇలా ఇచ్చాడు, ఆడ్స్ అగైనెస్ట్ ఎనీ ఈవెంట్ ఈస్ లైక్ దిస్ 6:2 అన్నాడు. odds against any event is 6:2. Then what is the probability of favorable events? Favorable అనేది ఎక్కడ ఉంటుంది? అగైనెస్ట్ లో రెండోది ఉంటుంది. సో 2/8 అని చెప్పాలి. ఓకే, అదే ఇక్కడ చూసుకోండి. ఫర్ ఎగ్జాంపుల్, ఇఫ్ ద ఈవెంట్ కన్సిస్ట్స్ ఆఫ్ డ్రాయింగ్ కార్డ్ ఆఫ్ క్లబ్ ఆఫ్ 52 కార్డ్స్, క్లబ్స్ ఎన్ని ఉంటాయి? 13 ఉంటాయి. సో దెన్ ఆడ్స్ ఇన్ ఫేవర్ అంటే ఏం చెప్పాలి? 13 ఏమో ఫేవరబుల్, 52 లో 13 ఫేవరబుల్ అంటే అన్ఫేవరబుల్ 39. 13:39 ఈజ్ ఆడ్స్ ఇన్ ఫేవర్ రేషియో. ఆడ్స్ అగైనెస్ట్ అంటే ఏం చెప్తాం? 39:13 అని చెప్పాలి. అలాగే ఆడ్స్ అగైనెస్ట్ ఏ కార్డ్ ఆఫ్ డైమండ్, డైమండ్స్ ఎన్ని ఉంటాయి నాన్న? 26. 13 డైమండ్స్ ఉంటాయి. 26 రెడ్ కార్డ్స్ ఉంటాయి, ఆ రెడ్ లో 13 డైమండ్స్ ఉంటాయి. 13:39 అగైన్. సో ఆడ్స్ ఇన్ ఫేవర్ ఏమవుతుంది? 13:39 అంటే 1:3 ఫేవర్. అగైనెస్ట్ అన్నాడు 3:1. ఆడ్స్ ఇన్ ఫేవర్ ఆఫ్ 4 or 6 ఇన్ ఏ సింగిల్ టాస్ ఆఫ్ ఏ ఫెయిర్ డై. 4 గానీ 6 గానీ రావాలి. 4 కి ఫేవరబుల్ 1, 6 కి ఫేవరబుల్ 1. 4 or 6 అంటే యాడ్ చేయండి. 2 ఫేవరబుల్ కేసెస్, 4 అన్ఫేవరబుల్, 2:4 లైక్ దట్. ఈ కాన్సెప్ట్ ఒకసారి చూసుకోండి. ఆడ్స్ ఇన్ ఫేవర్ అంటే ముందు ఫేవరబుల్ ఉంటాయి తర్వాత అన్ఫేవరబుల్ ఉంటాయి. ఆడ్స్ అగైనెస్ట్ అంటే ముందు అన్ఫేవరబుల్ ఉంటాయి తర్వాత ఫేవరబుల్ ఉంటాయి. ఆ రెండు యాడ్ చేస్తే టోటల్. టోటల్ అనేది ఎప్పుడు డినామినేటర్. ఫేవర్ అడిగాడా అన్ఫేవర్ అడిగాడా, అది ఆడ్స్ ఇన్ ఫేవరా ఆడ్స్ ఇన్ అగైనెస్ట్ చూసుకుని జాగ్రత్తగా చేయండి. నెక్స్ట్, ఎడిషన్ థియరమ్ ఆఫ్ ద ప్రాబబిలిటీ. 2 ఈవెంట్స్ ఆర్ నాట్ మ్యూచువల్లీ ఎక్స్క్లూజివ్. మ్యూచువల్లీ ఎక్స్క్లూజివ్ అయితే P ఆఫ్ A ఇంటర్సెక్షన్ B ఉండదు, కామన్ పార్ట్ ఉండదు. నాట్ మ్యూచువల్లీ ఎక్స్క్లూజివ్ అన్నాడు అనుకోండి, కామన్ పార్ట్ కూడా ఉంటుంది. అప్పుడు P ఆఫ్ A యూనియన్ B ఫార్ములా P ఆఫ్ A ప్లస్ P ఆఫ్ B మైనస్ P ఆఫ్ A ఇంటర్సెక్షన్ B అవుతుంది. When they are not mutually exclusive, there will be simultaneous event probability also. రెండు సైమల్టేనియస్ గా జరిగే ప్రాబబిలిటీ కూడా ఉంటుంది. సిమిలర్లీ దాన్ని ఎక్స్టెండ్ చేసుకుంటే P ఆఫ్ A యూనియన్ B యూనియన్ C. ఎక్కువగా ఈ ఫార్ములా అడుగుతున్నారు, ప్రాబ్లం కూడా చూడండి. ఓకే, నెక్స్ట్ కండిషనల్ ప్రాబబిలిటీ. వాట్ ఈస్ మీన్ బై కండిషనల్ ప్రాబబిలిటీ? దెర్ ఈస్ ఎ కండిషన్ దట్ వన్ ఈవెంట్ హ్యాస్ ఆల్రెడీ హ్యాపెన్, ఆఫ్టర్ హ్యాపెనింగ్ ఆఫ్ దట్ ఈవెంట్ అనదర్ ఈవెంట్ ఈస్ హ్యాపెనింగ్. కండిషన్ ఏంటి? ఒక ఈవెంట్ అయిపోయింది, దాని తర్వాత ఇంకో ఈవెంట్ వస్తుంది. అదే ఇక్కడ కండిషన్. అంటే డిపెండ్ అవుతోంది. ఒక ఈవెంట్ జరగడానికి ఆల్రెడీ ఒక ఈవెంట్ అయిపోయాక ఇంకో ఈవెంట్ జరుగుతోంది. డిపెండెంట్ ఈవెంట్స్ అంటేనే కండిషనల్ ప్రాబబిలిటీస్ వస్తాయి. ఓకే, సో ఇఫ్ ద ఈవెంట్స్ ఆర్ డిపెండెంట్, దెన్ ప్రాబబిలిటీ ఆఫ్ హ్యాపెనింగ్ ఆఫ్ ప్రైమరీ ఈవెంట్ వెన్ అదర్ ఈవెంట్ ఈస్ ఆల్రెడీ హ్యాపెండ్ ఈస్ నోన్ యాజ్ కండిషనల్ ప్రాబబిలిటీ ఆఫ్ దట్ ప్రైమరీ ఈవెంట్. If A and B are dependent events, then probability of happening A when already B is already happened, then a conditional probability antam. It is denoted by P of A given B. Given B means B is already happened, after that A is happened. Given B has happened, after that A is happening. Okay, so P of A given B formula, P of A intersection B by P of B. Here what is the condition? Our probability of B should not be an impossible event. 0 అవ్వకూడదు. B అనేది ఇంపాసిబుల్ ఈవెంట్ అయితే కండిషనల్ ప్రాబబిలిటీ డిఫైన్ చేయలేను. ఓకేనా? అలాగే P of B given A, P of A intersection B by P of A. Here P of A must not be an impossible unit. అంటే P of A 0 అవ్వకూడదు. ఓకే, ఇఫ్ A and B are two mutually exclusive అంటే ఏమవుతుంది? మ్యూచువల్ ఎక్స్క్లూజివ్ అంటే కామన్ పార్ట్ ఉండదు, జీరో అయిపోతుంది. P of A ఇంటర్సెక్షన్ B జీరో అయింది అనుకోండి, కండిషనల్ ప్రాబిలిటీస్ రెండు ఏమైపోతాయి నాన్న? జీరో అయిపోతాయి. సో అంటే కండిషనల్ ప్రాబిలిటీ ఎప్పుడు డిఫైన్ చేయడం? మ్యూచువల్లీ ఎక్స్క్లూజివ్ అయినప్పుడు కండిషనల్ ప్రాబిలిటీ డిఫైన్ అవ్వదు. ఓకే, ఇఫ్ ఏ అండ్ బి ఆర్ ఇండిపెండెంట్ ఈవెంట్స్ అంట. ఇండిపెండెంట్ అంటే ఏంటి? డిపెండ్ అవ్వట్లా. అంటే ఒక ఈవెంట్ అయిపోయాక ఇంకో ఈవెంట్ జరగడం ఇలా ఏం ఉండదు నాన్న, వేటికి అవే జరుగుతున్నాయి. వేటికి అవే జరుగుతున్నప్పుడు కండిషనల్స్ రావు. కండిషనల్స్ వచ్చినప్పుడు బి గివెన్ ఏ గివెన్ బి అంటాం. ఇండిపెండెంట్ అంటే ఏంటి? నో డిపెండెన్సీ. సింపుల్ గా P of A ఇంటర్సెక్షన్ B ఏమవుతుంది? P of A ఇంటూ P of B అవుతుంది. అంటే డిపెండెన్సీ ఉందనుకోండి, డిపెండెన్సీ అంటే కండిషనల్స్ వస్తాయి. ఆ కేసులో ప్రాబిలిటీ ఆఫ్ A అండ్ B అంటే P of A ఇంటర్సెక్షన్ B ఇలా రాస్తారు. P of A ఇంటూ P of B గివెన్ A గివెన్ B. B అయ్యాక A జరుగుతోంది ఇలా వస్తాయి. అదే ఇండిపెండెంట్ అనుకోండి, P of A గివెన్ B ఏమైపోతుంది? ఇండిపెండెంట్ కనుక P of B నే అవుతుంది. సారీ, ఇక్కడ P of B given A, sorry. ఓకేనా? క్లియర్లీ సీ హియర్ P of A ఇంటర్సెక్షన్ B. P of A జరిగాక B జరుగుతోంది అనుకోండి, P of A ఇంటూ P of B given A అంటాం. ఎప్పుడు? డిపెండెంట్ అయినప్పుడు కండిషనల్స్ వస్తాయి. అదే ఇండిపెండెంట్ అనుకోండి, P of B given A ఏముంటుంది? B A మీద ఆధారపడట్లా. అంటే సింపుల్ గా B కూడా B గానే వస్తుంది. దెర్ ఈస్ నో డిపెండెన్సీ. సో P of A intersection B equal to P of A into P of B అవుతుంది. ఇండిపెండెంట్ ఈవెంట్స్ ఇది. అని ఇక్కడ ఇంకొక పాయింట్, మ్యూచువల్లీ ఎక్స్క్లూజివ్ అయితే ఇండిపెండెంట్ అవ్వదు, ఇండిపెండెంట్ అయితే మ్యూచువల్లీ ఎక్స్క్లూజివ్ అవ్వదు. మ్యూచువల్ ఎక్స్క్లూజివ్ అంటే ఏంటి? P of A ఇంటర్సెక్షన్ B జీరో అవడం. జీరో అయితే ఇండిపెండెంట్ అవుతాయనా? అవ్వవు. ఓకేనా? దీస్ బోత్ విల్ నాట్ హ్యాపెన్ సైమల్టేనియస్. మ్యూచువల్లీ ఎక్స్క్లూజివ్ అయితే ఇండిపెండెంట్ అవ్వవు, ఇండిపెండెంట్ అయితే మ్యూచువల్లీ ఎక్స్క్లూజివ్ అవ్వవు. చూసుకోండి. సెకండ్, కండిషనల్ ప్రాబిలిటీ చూడండి. when A and B are independent, కండిషనల్ ప్రాబిలిటీ ఏమవుతుంది అని అడుగుతాడు. A and B ఇండిపెండెంట్ అంటే P of A ఇంటర్సెక్షన్ B, P of A into P of B. P of A given B ఏమవుతుంది అప్పుడు? P of A into P of B by P of B. P of A కి ఈక్వల్ అవుతుంది. P of A given B, P of A అవుతుంది. అంటే A and B are said to be mutually independent. ఇక్కడ అర్థం అదే చూడండి. P of A given B, P of A అయింది అంటే అర్థం ఏంటి? B జరిగాక A జరగట్లా, దేనికి అదే జరుగుతుంది, ఇండిపెండెంట్. సిమిలర్లీ P of B given A ఏమవుతుంది? P of B నే అవుతుంది ఎప్పుడు? ఇండిపెండెంట్ అయినప్పుడు. ఎందుకంటే వేటికి అవే జరుగుతున్నాయి. ఓకే, అలాగే ఇక్కడ ఈ పాయింట్ అడుగుతున్నాడు, A ఈ సబ్సెట్ ఆఫ్ B అయింది అన్న. ఇఫ్ ఎనీ సెట్ ఈ సబ్సెట్ ఆఫ్ అనదర్ సెట్, వాటి ఇంటర్సెక్షన్ ఏమవుతుంది? అదే సెట్. A ఈ సబ్సెట్ ఆఫ్ B అంటే A ఇంటర్సెక్షన్ B ఏమవుతుంది? A అవుతుంది. అప్పుడు P of A given B ఏమవుతుంది నాన్న? P of A by P of B అవుతుంది. P of B given A 1 అవుతుంది. B సబ్సెట్ ఆఫ్ A అయితే కనుక P of A given B 1 అవుతుంది. P of B given A, P of B by P of A. ఇంపార్టెంట్ పాయింట్స్, ప్లీజ్ రిమెంబర్. మల్టిప్లికేషన్ థియరం ఆల్రెడీ డిస్కస్ చేసాం. డిపెండెంట్ ఈవెంట్స్ వస్తే, కండిషనల్ ఈవెంట్స్ వస్తాయి కనుక P of A and B అన్నప్పుడు P of A into P of B given A వేయాలి. ఇఫ్ దే ఆర్ డిపెండెంట్, కండిషనల్ అయితే. అదే ఇండిపెండెంట్ అయితే కనుక P of A ఇంటర్సెక్షన్ B ఏమవుతుంది? P of A into P of B. టూ ఈవెంట్స్ A and B ఇండిపెండెంట్ అయితే P of A intersection B equal to P of A into P of B. 3 ఈవెంట్స్ ఇచ్చారు, ఇండిపెండెన్సీ చెక్ చేయమంటున్నాడు. ఎన్ని కండిషన్స్ అవ్వాలి అప్పుడు? 4 కండిషన్స్ అవ్వాలి. ఏమేంటండి అవి? ABC ఇండిపెండెంట్ అవ్వాలంటే AB ఇండిపెండెంట్ అవ్వాలి, AC ఇండిపెండెంట్ అవ్వాలి, BC ఇండిపెండెంట్ అవ్వాలి, ABC కూడా ఇండిపెండెంట్ అవ్వాలి. when there are 3 events, how many conditions we can develop for independency? 4 conditions. 2 events ఉంటే 2 events ఉంటే 1 AB ఇండిపెండెంట్ అంటే P of A intersection B equal to P of A into P of B. 3 ఈవెంట్స్ ఉన్నప్పుడు ఎన్ని కండిషన్స్ వస్తాయి? 4 వస్తాయి. ఓకే, దిస్ ఈజ్ అబౌట్ ప్రాబిలిటీ. నెక్స్ట్, ర్యాండమ్ వేరియబుల్స్. ర్యాండమ్ వేరియబుల్ అంటే ఏంటి? ర్యాండమ్ ఎక్స్పెరిమెంట్ మీద మీరు ఏదైనా వేరియబుల్ డిక్లేర్ చేసుకోండి. దట్ ఈస్ నోన్ యాజ్ random variable. Random variable is a real valued function defined on each and every outcome of the sample space connected with a random experiment. Number of heads when 2 coins are tossed అన్నారు. ఎన్ని రావచ్చండి? రాకపోతే 0 heads, వస్తే 1 head లేదా 2 heads. ఇదే ర్యాండమ్ వేరియబుల్ అంటే. ఒక ఎక్స్పెరిమెంట్ మీద ఒక వేరియబుల్ డిఫైన్ చేయండి, దాన్ని ర్యాండమ్ వేరియబుల్ అంటాము. ర్యాండమ్ వేరియబుల్ లిమిట్స్ ఆల్వేస్ రేంజెస్ ఫ్రమ్ -∞ to infinite, రియల్ వాల్యూస్, ఆల్ రియల్ వాల్యూస్. ఓకే, Here there is an example again. Consider a random experiment of two tosses of a coin, S equal to sample space. If we define a variable x as a number of heads, how many heads? Here S is taking none. In this case, TT case means 0 heads. Okay, na? In this case, TH, only one head. And in HT also one head. In HH case, how many heads it is taking? 2 heads. So 0, 1 and 2. Here X is known as random. Okay, how many types of random variables we have? 2 types: discrete random variable, continuous. Same as discrete variable, continuous variable. Discrete variable means it can take only integers, not decimals. Similarly, our discrete random variable will take only integer values. It will not take decimal values. Countable number of values means discrete random variable. Okay, number of heads in tossing 2 coins, 0, 1, 2, so on. It will not take decimal values. Okay, na? Number of heads will not be 1.5, 1.8 like that. Okay, so number of heads in tossing 2 coins is discrete. Number of points on a die is discrete. Number of births in a city is discrete. Number of accidents, all these are discrete random variables which can take only countable values. That means integers, not decimals. Continuous random variable can take any value between certain limits. Either it can take integers or non-decimals or decimals like that. Okay, so it can take any value between certain limits: age, weight, heights, etc. What is meant by probability distribution? If you have random variable values and corresponding probabilities, then such type of distribution is known as probability distribution. Consider the previous example. Tossing 2 coins, X denotes number of heads. 0 heads probability. 0 heads and how many cases are there for 0 heads? TT, only one case. Okay, 1 by 4. How many cases are there for getting one head? HT or TH? 2 cases, 2 by 4. 2 heads means only one case, 1 by 4. So random variable values and corresponding probabilities. This is known as probability distribution. Next, what is meant by probability mass function? If it is a discrete random variable and if we are defining a probability function, that probability function is known as probability mass function. Please remember, probability mass function is for discrete random variable case only. Random variable taking some value and we have to estimate that probability. We are assuming a function. That function is PMF and it should satisfy these two properties. P of x should be greater than or equal to 0 and total probability summation P of x is 1. For discrete case, E of x, expectation of x, that is nothing but mean. For discrete case, E of x is nothing but summation x into P of x. Okay. Similarly, E of x square means summation x square into P of x. From this, you can estimate variance. What is the formula for variance? E of x square minus E of x whole square. Okay, E of x square minus E of x whole square. For discrete case, this is how you calculate. E of x means mean, E of x square and variance. Similarly, probability density function. For continuous random variable, if we have defined a probability function, for continuous random variable, probability function is known as probability density. Discrete means PMF, continuous means PDF. Again, this PDF should also have satisfied two properties. F of x should be greater than or equal to 0. Total probability. In continuous case, there are infinite number of values, Nana. That means you can't add them. So summation will not get. So integral minus infinite to infinite. That means total limits. Area under total limit should be equal to 1. This is continuous case PDF. Similarly, in continuous case, mean formula E of x is nothing but integral x into f of x dx. In discrete case, summation x into p of x is the formula. In continuous case, for mean E of x, expectation of x is integral x into f of x dx. Take the limits corresponding to the problem. If the limits are 0 to 1, take integral 0 to 1. 2 to 3 means integral 2 to 3. In theoretical basis, integral minus infinite to infinite. E of x square means integral x square into f of x dx. After finding these two values, again, variance formula is nothing but same formula. V of variance of x is E of x square minus E of x whole square. This is about variance, probability density function. Okay, various formulas in continuous are like this. Okay. Next, we are going to distributions. Okay. Okay. Next, theoretical distributions. With the knowledge of probability, we can develop a frequency distribution and also a probability distribution for any variable. So the frequency distribution of certain population is known as theoretical distribution. Okay, this theoretical distribution will be helpful in decision making. Okay, you can find probabilities, future probabilities like that. So these discrete theoretical distributions can be classified into two types. One is discrete probability distribution, another one is continuous probability distribution. Discrete probability distributions means discrete random variable cases. For those discrete random variable cases, we are defining different probability mass functions. Then you will get binomial distribution, Poisson distribution, which come under discrete distributions. In continuous distributions, our important distribution is normal distribution. That means there will be a probability density function since it is a continuous case. Now directly we will move on to binomial distribution. It was discovered by James Bernoulli. Okay, Bernoulli. What is meant by Bernoulli variate? A variate which assumes only two values, 0 and 1. That variable is known as Bernoulli variable. What is meant by Bernoulli trial? When a trial results only two outcomes, success and failure, that is known as Bernoulli trial. Like that, a single trial means Bernoulli trial. Like that, we have taking n Bernoulli trials, then it will come under binomial distribution. See here, it is the discrete probability distribution which is used to find number of successes resulted when an experiment is repeated number of times. Okay, a number of times means n number of times we are repeating an experiment. Out of n number of times, suppose what is the probability of getting x number of heads? Then you can find it by using PMF, NCX, P power x, Q power n minus x. So binomial distribution PMF is NCX, P power x, Q power n minus x. What are the conditions for applying binomial distribution? When an experiment is repeated number of times, that means n should be finite. We must know the n value. Suppose 10 times coin is tossed, n is 10. Suppose 6 times die is rolled, n is 6. That n should be known. Number of trials should be large, but it is finite. Okay, n value should be known. N is known. But probability of success for each trial should be constant. That means how many, when you have tossed a coin even 100 times, on not 1th time also, what is the probability of getting head? 1 by 2. First trial also probability of getting head is 1 by 2. Second trial also 1 by 2. That means probability of success will never change. So in that cases, you can apply binomial. N is finite and P, success probability, is constant. When in these both cases, you can apply binomial distribution. The variable should be discrete. Discrete means it should not take decimal values. Okay. So what is the PMF of binomial distribution, Anna? NCX, P power x, Q power n minus x. This is the probability mass function of binomial distribution. Here n denotes number of trials. P denotes probability of success. Q denotes probability of failure. And what is x? Number of successes. N number of trials. What is the probability of getting x number of successes in n number of trials? NCX, P power x, Q power n minus x. Here, this is one important point. Binomial variate should take the values 0, 1, 2, so on n. 0 means getting 0 successes, 1 means 1 success, so on. How many success you can get in n number of trials? N success only. Okay, na? So binomial variate will assume the values from 0, 1, 2, so on n, both inclusive. 0 can also be taken, n can also be taken, and between values. Here remember one point, all are discrete values. That means only integers only. Whole numbers, not whole. Okay, whole numbers only. Whole numbers means 0, 1, 2, so on n, not real numbers. Sorry, not real numbers, only whole numbers. 0, 1, 2, so on n. Okay, so please remember, NCX, P power x, Q power n minus x is PMF of binomial distribution. P is success, Q is failure. Always P plus Q is equal to 1. What are the main properties and what are the main points you have to remember in binomial? Binomial distribution parameters are n and p. There are two parameters for binomial distribution. Biparametric discrete distribution. So what are the parameters of binomial distribution? N comma p. And it is denoted by x follows b of n comma p. X is a random variable following binomial with parameters n comma p. Okay, suppose in problems if he has given like this, x follows b of 10 comma 1 by 3, that means n is 10 and probability of success p is 1 by 3. Okay, so n and p are binomial parameters, so it is known as biparametric discrete distribution. Mean of binomial distribution is np and variance is npq. If it is asked as SD, root NPQ is the SD of binomial. Coming to mean and variance, always mean is greater than variance for binomial. Always NP is greater than NPQ. Okay, so mean is greater than variance. For binomial distribution, mode may be unimode or bimode. Sometimes it may take one mode, sometimes it may take two modes. What is the formula for mode? N plus 1 into P. So suppose if N plus 1 into P is an integer value. Integer means exact value. Then we will have two modes, n plus 1 into p and n plus 1 into p minus 1. Suppose after calculating n plus 1 into p, suppose, okay, p is 1 by 2 nana and n is some 7. Then what is n plus 1 into p? 7 plus 1, 8. 8 by 2 is 4. So mode n plus 1 into 4 p is get 10. We got it as 4. When it is an exact value, consider it as two modes. That value 4 and before n plus 1 into p minus 1, 4 minus 1, 3. So in this case, we will have, two modes. What are those two modes? Bimodes? 4 and 3 or 3 and 4. Okay. When n plus 1 into p is exactly an integer, binomial distribution will have two modes. If n plus 1 into p is non-integer, that means if n is 6 here and p is half, 6 plus 1, 7 by 2, 3.5. N plus 1 into p, 3.5 means it is not an integer, decimal value. In that case, consider integral part as mode. 3.5 means 3 is the only mode. Okay, so binomial distribution may have unimode or bimode. So based on n plus 1 into p value, if n plus 1 into p is exact value, there are two modes. That value and before value, n plus 1 into p is non-integer value, that is decimal value. Integral part of the decimal value is mode. Next, the parameters are n and p. Already we have discussed. Both are positive. Binomial distribution is a biparametric discrete distribution. Next, binomial distribution, sometimes it is symmetric. When p equal to q equal to half, it is symmetric distribution. When p is half and q is half, binomial distribution is symmetric. Okay. Similarly, binomial distribution is positively skewed when p is less than half and q is greater than half. In that case, binomial distribution is positive skew. Similarly, when p is greater than half and q is less than half, in this case, binomial distribution is negatively skewed. And whenever p equal to q equal to half, both are half, in that case, binomial distribution is symmetry. Okay. So based on p and q values, it is sometimes symmetry, sometimes positive skew, sometimes negative skew. Please remember these points. Okay. The variance of binomial variate attains maximum value at p equal to q equal to half. Half means 0.5. So what is the formula for variance? NPQ. When p and q becomes half, half and half, 1 by 4. So maximum value of variance formula for binomial distribution is n by 4. Okay. The terms in binomial distribution can be found with the expansion of q plus p whole power n, not p plus q whole power n. Q is the main part played here in binomial distribution. Okay, q plus p whole power n. Already I have discussed this point. P equal to half means binomial is symmetric. P less than half, that is q greater than half, it is positive skew. P greater than half, q less than half, it is negatively skewed. Okay. Mean is NP, variance is NPQ, mu3, thought center moment, NPQ into Q minus P, mu4, NPQ into 1 plus 3PQ into N minus 2. In this, mean and variance are important. Please neglect mu3 and mu4, not necessary for this attempt. Okay. Poisson distribution. After binomial distribution, when you are applying binomial, when N is finite or known value and P is constant, you are applying binomial. But coming to Poisson distribution, n is not known value, n is infinite, and in those infinite number of trials, probability of getting success will be very small, nearly equal to 0. In these cases, you have to apply Poisson distribution. Okay, when n is infinite and p equal to m by n, that is probability of success in n trials, m by n is a small value, then we use probability law of Poisson, which is e power minus m power x by x factorial, or sometimes he may give like this also, e power minus lambda into lambda power x by x factorial. Okay, here e value is a standard value, Nana, 2.7813. X is nothing but 0, 1, 2, so on infinite. Here, this is one important point. In binomial variate, we will assume the values from 0, 1, 2, so on n, where n is known value. So up to n, we will get the values. But coming to Poisson variate, we will assume the values 0, 1, 2, so on infinite. Okay. So anyway, here E is standard value. X is also a standard value, 0, 1, 2, so on infinite. Which value we have to know? Lambda or m. So in Poisson distribution, lambda or m is considered as parameter. When should Poisson distribution apply, Nana? As I discussed earlier, n is very large and success is very small, very rare, very rare. So Poisson distribution is known as distribution of rare events. Some of examples: number of deaths in a city in 1 year by a rare disease. It will not happen regularly. It is a rare. Okay. Number of accidents during a day. It is also rare event. Number of telephone calls received at a particular telephone exchange in some unit of time. It is also rare event. Incoming calls for a telephone board is not a very rare event. Okay. Number of suicides, number of typing mistakes in a page of a book. These are all rare events. In such cases, you have to apply Poisson distribution. What are the properties of Poisson? As I discussed earlier, the parameter in Poisson distribution is m or lambda. Uniparameter, only one parameter is there. It is uniparametric distribution. Poisson distribution mean is lambda and variance is also lambda. That means mean equal to variance. For polynomial distribution, what is the condition? Mean should be greater than variance. For Poisson, mean equal to variance. Okay. So mean equal to variance equal to lambda. If it is SD, root lambda. Okay. M equal to lambda equal to NP. Whenever n is given known value and success probability is also known, but n is very large. Suppose in 100 number of trials, probability of getting success is 1%. Then in that cases, you can apply Poisson distribution where n is 100 and probability of getting success is 1%. That means 1 by 100. In this case, you can't apply binomial distribution. For this case, you can apply Poisson with parameter NP. Okay, n into p, 100 into 1 by 100, lambda value becomes 1. Okay, so in this case, you can apply Poisson. When lambda equal to np and n is very large and known value, n and p are known, you can use Poisson distribution instead of binomial. Poisson distribution is always positively skewed, positively skewed distribution. But whenever lambda value or m, that means mean value increases, then Poisson distribution will give rise to symmetric. Symmetric means normal distribution. Okay. Mode for Poisson distribution is also equal to m or lambda. According to these m value or lambda value, again we can decide whether it is unimodal or bimodal, as same as binomial. If m value is exactly an integer, suppose m equal to 3, then 2 and 3 are modes, bimodes. That means when m is integer, that value and previous value should be considered as modes by mode. If m is non-integer, suppose m is 2.8, then 2 is the mode, only unimode. That means m is non-integer means integral part is mode. So Poisson distribution is also unimodal or bimodal according to the m value. Okay, please be careful. Poisson distribution is always positively skewed. When m is very high, it becomes symmetric normal. Okay, mean is lambda, variance is lambda, SD is root lambda, mode is lambda. So mean equal to variance for Poisson. That is about Poisson. Okay. Next very important distribution is normal distribution, which is a continuous probability distribution. That means probability density function will be there. It was actually given by Gauss, so it is also known as Gaussian distribution. So random variable x is said to have normal distribution with mean mu and variance sigma square if it's PDF. Please remember the PDF of normal distribution. 1 by sigma root 2 pi e power minus 1 by 2 x minus mu by sigma whole square. Okay. So this is the PDF of normal distribution. Here x is continuous random variable. That means it can assume any value between certain limits. Certain limits. Okay, na? And any continuous random variable will not take specific value. It always take the value between certain limits, less than, greater than, or in between only. Okay, please remember that. So here normal variate limits are minus infinite to infinite. So normal distribution parameters in this PDF, E value is known value 2.7813. Pi value is 22/7. Only the values which we are going to know is mu and sigma square. So what are the parameters of normal distribution? Mu and sigma square. It is denoted by x follows n mu sigma square. That means x is a normal variate with parameters mu and sigma square. That means in problems he may give like this. X follows n of 50 comma some 36. So what is mu value? 50 and sigma square 36. Okay, like that. Anyway, this is the PDF of normal distribution. So normal distribution can be converted to standard normal distribution by taking z equal to x minus mu by sigma, which is known as standard normal variate. Standard normal variate. When x is converted to standard normal variate, our PDF will be converted like this. 1 by sigma root 2 pi e power, okay, here 1 by sigma root 2 pi e power minus 1 by 2. Here x minus mu is taken as x by sigma whole square. Sometimes PDF is also given like this. Coming to z value, z is standard normal variate. Then our PDF is 1 by root 2 pi e power minus z square by 2. Sigma becomes 1. So what is the PDF of standard normal? 1 by root 2 pi e power 1 by root 2 pi e power minus z square by 2. Okay, this is the PDF of standard normal distribution. Here, coming to normal distribution, mean is mu and variance is sigma square. Coming to standard normal distribution, mean will become 0 and variance will become 1. These are the important points. And now I will go to more important points which you have to remember in normal distribution. The area under the normal curve is found from the table of a standard normal probability distribution, which is area between 0 and any value of the normally distributed normal variable. That means standard normal variate. That means between 0 and z, the value will be given from standard normal tables. For that values, from using that values, you can find all other probabilities. For any given value of mean mu and SD sigma, standard normal variate formula is z equal to x minus mu by sigma. Okay, properties. Normal distribution is a symmetric distribution, symmetric or normal, both are mean, and it is symmetric at x equal to mu, bell shape. So suppose if normal distribution is a bell shaped curve like this, it is exactly symmetric at x equal to mu. Mu means mean here. Okay, symmetric means mean, median and mode all will be equal, but normal distribution is symmetric at which point? Mean point, mu. Mean is mu, mean. Okay, you have to say it as mean. Mean, median and mode are equal. Quartiles are equidistant from mean. According to ICI, please follow that one only. Quartiles are equidistant from mean. Here mean, median and mode are all equal, but in center we are saying it as mean. So according to ICI, quartiles are equidistant from mean. Okay. The top of the bell is directly above the mean mu. Top of the bell means it is symmetric at x equal to mu. For normal distribution, mean is mu, variance sigma square. Whereas for standard normal, mean is 0 and variance is 1. Normal distribution, QD, MD, SD ratio is 10:12:15. And the relation is 6QD equal to 5MD equal to 4SD. Mean deviation about mean, MD is 4/5 sigma or 0.8 sigma for normal. In standard normal, sigma will become 1 and mu will become 0. Mean is 0 and SD is 1. Okay, and this is another important point. For standard normal distribution, variance is 1 and SD is also 1. That means variance and SD are equal for which distribution? Standard normal distribution. Mean and variance are equal for which distribution? Poisson distribution. Okay. MD is 4/5 sigma or 0.8 sigma for normal. If it is standard normal, write it as 4/5 or 0.8. Okay, similarly, QD is 2/3 sigma for normal distribution or 0.675 sigma. If it is a standard normal, it is simply 2/3. Okay. First and third quartiles, Q1, mu minus 0.675 sigma and mu plus 0.675 sigma for normal distribution. If it is a standard normal, then minus 0.675 and plus 0.675 will be the Q1 and Q3 for standard normal. The area to the right of the ordinate as well as the left. That means the area between minus infinite to mu is 0.5, which is known as left side area, and mu to infinite is 0.5, which is known as right side area. Left side area is 0.5, right side area is 0.5. The total area under normal curve means total area 0.5 plus 0.5 is 1. Total area under normal curve is always unity 1. Okay. Here, area property is one of the important property. Nana. So between minus 1 and plus 1, mu minus sigma and mu plus sigma, 68.26% will lie. Between minus 2 and plus 2, mu minus 2 sigma and mu plus 60 sigma, 95% will lie. Between minus 3 and plus 3, mu minus 3 sigma and mu plus 3 sigma, 99.7%. This rule is known as 68, 95, 99.73 rule. Okay, 68 between minus 1 and plus 1, the area will be 68%. Between minus 2 and plus 2, the area will be 95.5% or 95. Between minus 3 and plus 3, what is the area? 99.73. That means almost the values will lie between minus 3 and plus 3, Nana, but outside limits 0.27%. This is an important point. See here. We note that about 99.73% values lie between mu minus 3 sigma and mu plus 3 sigma. Probability that a value x lies outside is only 0.0027. Okay, na? So similarly, the area lying between minus 1.96 and plus 1.96 is exactly 95%, and minus 2.58 and plus 2.58 is exactly 99%. Area property, one of the important property. Okay. Normal curve is always unimodal. Coming to binomial and Poisson, they are sometimes unimode and sometimes bimode. ఒకసారి ఒక మోడ్ ఉంటాయి, ఒకసారి రెండు మోడ్స్ ఉంటాయి. Binomial Poisson. Normal ఎప్పుడు ఒక మోడే, unimode, always unimodal. మోడ్ కూడా ఎంత? mu. Mean ఎంత? mu. Median ఎంత? mu. Mean, median and mode all are equal for normal. Okay. Points of inflection. What is meant by points of inflection? In normal curve, actually the curve is like this. Okay, na? It is like cup, bell shape. That cup shape will become cap shape at some two edges. These two edges, okay, these two edges are known as points of inflection. Mu minus sigma and mu plus sigma. Exactly in center there will be mu. Left side is mu minus sigma, right side mu plus sigma. Points of inflection of normal are mu minus sigma, mu plus sigma. Coming to standard normal, what are the points of inflection? Mu will become 0 and sigma will become 1. So standard normal points of inflection are minus 1 and plus 1. Okay, very important. Similarly, first four moments of normal distribution are mean 4, variance sigma square, third central moment mu 3 0, mu 4 3 sigma power 4. And for normal distribution, skewness, that is beta 1 0. Skewness 0 means it is symmetric. Skewness is absent. Skewness 0, symmetric. Beta 2 is kurtosis, Nana. It is a bell-shaped curve. Beta 2 will become 3. It is mesokurtic. Beta 2 3 means exactly bell-shaped. Okay. These are the moments of normal distribution. So that is about distributions also. Okay. So please concentrate on theory, Nana. Statistics lo meekunna flexibility endante theory untundi, problems untayi. సో మీరు స్కోరింగ్ చేయగలరు అనుకుంటే ఈ పేపర్లో స్టాట్స్ ద్వారా థియరీ బిట్స్ కూడా ఉంటాయి కనుక స్కోర్ చేయొచ్చు. కాన్సెప్ట్ అర్థం చేసుకోండి. మనకి ఇంపార్టెంట్ కాన్సెప్ట్స్ ఏంటనేది మీకు తెలుసు ఇప్పటికే. ఆ కాన్సెప్ట్స్ అన్ని ఒక్కసారి రివైజ్ చేయండి. ఎగ్జామ్ ఇంకొక 4-5 days లోనే ఉన్నాయి. కొత్త టాపిక్స్ అయితే ఇప్పుడు టచ్ చేయొద్దండి. కొత్త టాపిక్స్ టచ్ చేయదు. ఆల్రెడీ మీకు తెలిసిన టాపిక్స్ రివైజ్ చేయండి. దాని మీదే ఎక్కువ పట్టు సాధించండి. ఓకేనా? నో నీడ్ టు వర్రీ. You are going to write your exams in a beautiful manner. Okay, na? Thank you for supporting. Please subscribe to my channel, Nana. Please subscribe, like and share. More suggestions, you are welcome. Okay, thank you. All the best for your exams. Okay, if you have any doubts, please comment me. I will clarify your doubts also. You are welcome. All of you are welcome. All the best. Thank you.